dignitaries present. Just sharing my screen. I would just like to start with a small video which would show the significance of my particular topic. Hope the video is visible.
Yes.
Fine. Actually, see, this video is showing the role of humanoid robots, especially during the COVID-19 scenario. Right. So this actually video was forwarded by one of my friends, and from one of the groups probably has got a forward. And I found it very useful because this is basically faced by every nation in the world, that people are not following the basic COVID protocols. They are supposed to maintain safe distancing, mask, as well as they are supposed to obey all the rules that are laid down by the respective governments to fight against COVID-19. So this is lacking. And wherever human intervention is there again, there's a risk of COVID being spread to different people. So actually, if we have a police monitoring this would not be that much fruitful compared to what we are getting through humanoid robots. Also, one important thing is that during this particular video, there was one humanoid robot which was providing vaccination door to door. That is, the humanoid robot is going, knocking on the door just like a normal person. And accordingly, they can check the credentials, and that can be the individual or the family can be vaccinated. So this is something which we are looking at going into the future. Maybe in India also this is starting to be implemented, though it may take a lot of time. But I think so by 2025, we would have a lot of changes in the way we are going about the existing things. Like role of humanoid robots would increase, and this is going to lead to a smart environment. Also, I would like to start with a small note that smart cities and smart villages are going to be implemented in India and in many other developing countries also. And we are looking at robotics or humanoid robots playing a major role in smart environment or smart cities. So I'm going to start with my topic with the background of that I've given right now. My topic is role of humanoid robots in smart environment. I would start with rural education. This is a project which I'm actually doing right now, where what I've found is that there are a lot of gaps in the rural education in the government schools, especially in India. In Gujarat, I have surveyed many schools, and based on a Times of India and Indian Express survey also of 2017-18, it was found out that there's a lot of lacking in the education standard of the schools, because the primary school teachers are actually given additional duties, there's shortage of staff. There are a lot of other issues which we have identified. So I've just listed out the problems in rural education and how humanoid robots can play an important role here. So the first thing is lack of quality education and standard study materials, because the connectivity is not there. There is no option but to learn from the particular teacher who is recruited for that purpose. So they don't have any other option. Students don't have any other option. Lack of expertise related to domain area, that is again a major issue, because if I say that we don't have an expert on a particular subject, say suppose for computer related subject, they don't have an expert, then they would be dependent upon either getting somebody from outside, which is not feasible enough. So there are options given here where a robot can take the place of a teacher in that case. Infrastructure and connectivity issues, of course, nothing can be done about this because this is a major issue, and this is dealing with the government providing the infrastructure. But that is also slowly and constantly it is developing. So we are looking at this issue being removed very soon. Lack of industry-oriented skills and ICT advancement. Now we are not, mainly robotics have been doing mechanical jobs. We have not asked, or we have not involved them much into the intellectual jobs as such. So we are looking at doing this right now, and our project is regarding this only, that humanoid robot would be taking the place of a teacher, or maybe supplementing a teacher in the roles that can be given for the teacher. Like suppose if I say assignment checking, some basic information being provided to student. There are many other roles which can be taken, and students are finding this very interesting. When this experiment was conducted, students are finding robots very interesting when they are dealing with education. There are lack of basic amenities again in most of the places. Funding utilization, funding is quite low comparatively, and whatever funds are provided are not utilized. So we need to look at that. Mindset of the stakeholders is very important. And normally, as I told you, that teachers are very less and they are used for other administrative work. Like in India, you will find that mainly that most of the teachers are given some other work, like counting of population, census calculation, everything, all this related administrative work can be given to a teacher. And that is actually disturbing the academics. And low literacy level among the villagers, that is leading to this problem. So as I told you that there was a survey done by a newspaper, English newspaper, Indian Express, as well as Times of India separately. I've just added the problem description here, that 18% schools needed immediate repair. These are infrastructure related issues. Class-wise performance by social groups, everything was done. The boys and girls performance was also compared. It was found out that probably we are lacking in basic quality education being delivered. So there are a lot of issues regarding this. That third standard, a student was actually asked some basic questions. Now, he was not knowing even the answers of which a first standard student should know. So this was the majority of the performance output that was received during the survey. So this was an alarming fact. For this, actually, some experiments are going on right now. As I told you that we are also doing a project which is dealing with humanoid robots in rural education. There has been, for in the urban side, there have been a lot of experiments going on. Like in Japan, you have robots into education. You have in Bangalore, they have an experiment conducted by Indus International School, where they have actually supplemented a robot in addition to a regular teacher in the class. So this gentleman standing here is a regular teacher with a tie, and this lady over here actually is a humanoid robot. Actually, she's not a teacher. She's a humanoid robot who is actually trained to be a teacher. And this humanoid robot is actually conducting the or teaching the students on the basics as well as advanced concepts of that subject. And this humanoid robot is also equipped to check the assignments of the students, take a viva of the student. All these things are being done by this humanoid robot. So this is something which probably the students also find it interesting, and it would soon be replacing the regular teaching that we are undertaking in schools. As I told you, in Japan, in China, these robots are already being used in education in a big way. And students are finding it very interesting. In Japan, there's a huge shortage of young staff who can in various places. So they are using robots very effectively. So this is, I think, so some of the aspects that we need to look at. Second aspect which need to be given in a smart environment is healthcare. Healthcare sector has to be smart. For healthcare sector to be smart, actually, right now, since the last 1.5 to 2 years, especially after January 2020, we have found that due to COVID, a lot of restrictions have come, and healthcare sector has actually been seen a major transformation, or is seeing a major transformation. We have seen a lot of challenges coming here because people are have to be admitted in hospitals. They are not getting beds. During the first and the second wave, we saw a lot of problems being faced by the patients also, by the doctors also, by health infrastructure is also missing comparatively the level which it should be there. So a lot of issues are there, and doctors are at a major risk. Healthcare workers are at a major risk because they are interacting directly with the patients. Now, whenever any patient is coming, patient maybe is infected with COVID. Now, immediately, the first concern is, are the doctors safe? Are the nurses safe? Are the ward boys safe? Probably not in our system. So this particular robot can take a role of a ward boy, take the role of a nurse, take the role of a doctor, and there's a webcam attached here. If you just see here, there's a webcam attached here, and this robot actually, through this robot, the doctor or the nurse can interact with the patient in a very effective manner. Not only that, this robot has a lot of skills that is required of a nurse. So it has been trained through AI and machine learning. The model has been created wherein this particular robot is able to handle all the patient's requirements. Only when there is any serious emergency or any serious case, the doctor has to attend. Otherwise, doctors can monitor these robots and give them instruction on how to actually go ahead with the treatment. Even the medicines being given can be monitored by this particular nurses sitting in their own cabins. So they don't need to go to the particular patient ward. So there are less chances of getting infected. Along with this, this is actually, this robot is called Grace, the healthcare robot that COVID-19 has created. And a lot of such experiments are being conducted at various places. So healthcare is being transformed in a big way using robotics. I have not included this because of lack of time, but there are many such other things also which a robot can do. One more thing which a robot can do is that whatever the ward needs to be cleaned, because hygiene is also a major issue here. So whenever COVID ward is there, normally the healthcare workers are not preferring to go to the COVID ward to clean the ward, etc. So for that purpose, also humanoid robots can be used who can do the cleaning job. So this is how we can transform the healthcare sector in a big way. In military also, we can have robots along with drones. We can have proper robots also, which can actually fit how we are dealing with the military solutions. You can have a robot actually taking the role of a soldier, and these robots are actually very much equipped with the latest machines and the latest machinery. Even they can be given a gun also, they can operate a gun also, they can operate bombs also. So these are specialized robots which are prepared. As I told you here, I've just listed out these things. Multi-physics sensors are there. You have carbon fiber reinforced legs, so they make it quite brisk for them to run also if required. And they have an active balancing tail, so nobody will suspect this robot, or even if they suspect it, the robot is equipped enough to meet the challenges and even face the enemy. So this can be a good alternative wherever terrorists are involved. If terrorist attacks are taking place in some areas, that this robot can be used. Also for military operations, it can be used. So again, robotics is transforming the whole environment in a way. Now, this is how we are looking at a typical office post-COVID. Right? Whatever earlier office scenario we had seen, here we have a touchless entry. basically what we are looking at in the crux, if I tell you, we don't want physical interaction between people. That distance should be maintained. There should be remote collaboration tools. There should be a kind of a touchless entry system. So a lot of concerns that are being addressed here post-COVID. We are looking at office in such a scenario, and we are also training robots for this purpose. Like suppose in an office, robot can be used for daily operations where you are looking at solutions of people being served snacks, tea, etc., or files being transferred from here to their physical files. That can be done by a robot. So robot can actually do all these jobs along with intellectual jobs also. So in an office scenario, this is what we are looking at. Toilet cleaning VR robot, these are already operational at many places, and they give a better hygiene, as well as they are infection proof. That is, they don't spread infection from one place to another. So this is a very good way of looking at cleanliness through a robot. Now, one project which is very close to my heart after rural education is waste management system. Now here, though this model does not cover a robot exactly, but I'm going to fit in a robot over here for all these tasks. Like normally what happens is that this is a typical model of smart AI and IoT based waste management system. If I combine a robot over here, what would happen is that robot is going to control how the waste collection is taking place. That means here we have a smart bin here, which has sensors and which has identifiers. And it is programmed in such a way that whatever waste is collected, it can be separated into different compartments, like dry waste, wet waste, plastics. Everything can be separated into different compartments, so that it is easy for the waste collector person or the machine to identify and collect that waste accordingly. So this is a very smart device. Along with this, we have a system wherein we also have a garbage can system, which is smart enough to notify that 75% of the garbage, this particular dustbin is full. So it can give a notification to the authorities that this dustbin needs to be emptied now. So the collection can also be controlled properly with the help of this. For route detection also, there are various machine learning algorithms. So which route to go, all these data generated through this particular dustbin, everything is stored in a cloud database. And this is very well monitored by different agencies. It can be monitored by the healthcare department. It can be monitored by the municipality. It can be monitored by local societies. So this collection can be very much efficient. Now, where robots can be involved is that still many times what happens is that in India we face, and most of the developing countries, we face this problem that whatever waste collection is taking place, that is taking place or that is done by workers, sanitization workers or hygiene collection or waste collection workers who are actually municipal employees, but they don't have any kind of protective gear that they are using for their hygiene purpose or health purpose. They are collecting all the waste with their bare hands. And sometimes it happens that this garbage van, which we call this garbage van, they are standing at the back, and around them is a huge dust collection, or you can say waste collection. So they are at a risk of a lot of problems, a lot of health related problems. So here robot can take that job of collecting the waste. Only the monitoring need to be done by those workers. So this is something which we are looking at in a very serious manner. And in India, this is very much required because we are looking at bio waste, biomedical waste. Actually, you can see masks, you can see syringes, everything is in the same dustbin. So it's a lot more hazardous for the healthcare workers, for the workers, sanitization workers, everyone who is involved in this operation. And recycling also is a big challenge. So again, here robots can be used for that purpose also. These are garbage sorting robots, as I told you. They can be used for separate sorting of this particular items, that they are separating the waste based on their types. Agriculture, we have seen a lot of robotic use, AgriBot. Recently, actually, I just gone through one article where IBM has conducted an experiment. They've used robots for farming and they have found very good results out of it. Along with AI and machine learning, robotics is also being used. So this AgriBot is capable of a lot of things, just like the farmer is doing farming, it is capable of farming. Again, here, these are all devices which are used with AI and machine learning. Now we can have, suppose many times it happens that this disinfectant machine is there. Now, many times it happens that it is operated by human beings. What I mean by human beings is that if the disinfectant machine does not contain the sanitizer or hand wash, etc., then that needs to be filled. So that filling process can also be done by a robot. So robots can take over the entire job that is required. I've already talked about waste management, but here again, these garbage cans are separate and they can be monitored by the robots also very nicely. So robots are an alternative to this. Police can also be, we are having traffic police right now in traffic signals, though many places this e-challan system is there, wherein if you are flouting the traffic norms, you would be given a particular e-challan directly. You will not be asked to pay to anybody, but it will be directly transferred to you at your home, and you are supposed to pay the money directly into the account. So this traffic signal or any riots are going on, any mob is there, during election time, there is any violence, then robots can be effectively used for this purpose. We are not expecting the manual police to go there and do the job because it is very risky. So humanoid robots can be a very good alternative. We have in many of the hotels right now, they have, instead of a security guard standing there and giving you instructions on where to park your vehicle or doing the valet parking, we can have AI powered robot assistants who can actually do the job of security guard as well as valet parking solutions also. Now, along with this, I'm also looking at drones being used. So if you have drones and robots being used effectively, then it can be a very good solution for many such problems that we are facing. So my idea of a good environment or smart environment is that future farms, I expect it to be of this kind, where the farmer is sitting over here. He has all the access to the farming data sitting in his office. He's just doing his job like a corporate worker. He is not a corporate officer. He is not involved in actual farming. He's just monitoring how the farming is being done through drones, through AgriBots. They may have robots also, which can actually take the place of monitoring different other things that is required here, like just like the when to use a particular drone that can be monitored by the robot, in addition to the farmer also. So this all solutions lie over here. That RFID tags are there with the cows here. So all the data regarding the cow, what it has eaten, everything is reaching the farmer. Where the cow is can be located by the farmer. So we are looking at all these solutions. I would like to add one more component here, is that autonomous vehicle, that is a smart farm tractor, is also in place over here. So these are all the changes that we are looking at in the future. Maybe it may take a few years, but definitely I'm very positive about the changes that is happening. So this is what I was explaining here, that supply chain can be improved. We can have quality certification at various stages, because we are using blockchain, AI, robotics, everything together. So blockchain would give the certification, quality certification at various stages. Suppose a farmer is producing something and some customer or some company who is buying the farming products, they want to monitor that what stages the farm product has gone through, then that can be obtained through blockchain. So this is a very good model which we can follow, which is a mixture of all the technologies which can help in lot more solutions being vetted out to the people. Again, this is what smart environment looks like. We are looking at all smart solutions where you don't have human intervention. The best part over here is that human intervention is close to zero. So when human intervention is close to zero, then everything has to be automated. Either it should be automated devices or it should be robotics. So these are the solutions that are there with us. Again, these are all examples where I'm talking about image processing combined with robotics to give you better solutions for traffic management. So all in all, like role of robotics in factories can be to improve the value chain, potential to reduce the operational cost because this is a one-time investment. And right now, just before a few months, I had gone through that in one village in India, one villager has developed a robot out of e-waste. So humanoid robot was normally costing close to 3 lakhs, from 3 lakhs to 20 lakhs per humanoid robot based on the tasks that it performs. But right now, we are looking at that cost being reduced to almost 40 to 50,000. So this is a welcome change here. So we can reduce the operational cost because one-time investment is there. You're going to get a lot of returns out of it. You're also going to give a lot of benefits to the people because it will not lead to loss of jobs. It will actually lead to such a situation wherein we can skill the labor people and they can be given monitoring jobs. So their role would increase. Their package and quality of life would also increase. So increasing productivity is one of the jobs that we expect out of robots. Then robots are minimizing the errors or delays. So that is a very good job. I mean, we have implemented this in one of the places. There's a ceramic hub in Morbi. It's called Morbi in Gujarat. It's almost 100 kilometers from Rajkot. So there are a lot of ceramic units. So that ceramic units, mostly they are automized, but when the tiles are coming out, finished goods, at that time they have to be separated into different quality of tiles: premium quality, normal quality, average quality, or maybe it needs to be rejected because these tiles are exported. So they need to be classified according to the quality. Now that is done by manually through the conveyor belt. When the tile is coming out, you have hardly 2 seconds to decide which quality that tile is. So there can be manual errors during this. Also, these manual laborers are being paid close to 30 to 40,000 per month per person for doing that job. So we have replaced this with humanoid robots wherein they can do it much more better in a much more better manner with the help of image processing also. And this has yielded a lot of savings for the people. So what I mean to say here is that whatever tasks we think that human being can be replaced with robots, which are hazardous or which lead to a lot of errors, that should be done by robots. So my mantra for this particular third wave, we are preparing for the third wave now. We are preparing, I'm saying, because most of the people are trying to bring the third wave faster than it is normally going to come by not heeding to the norms. So my mantra for them is, new normal mantra is, be socially connected, but maintain physical distancing. So this is all from my side. If any questions, I'm open to it.
My report, okay. My report today is about interfacial engineering of PTA perovskite for improved hose extraction in efficient inverted Pscs. My research area in the former 3 years is about photovoltaic. So it's my great honor to be here to attend the second global webinar on applied science, engineering, and technology. Thanks for the committee members. Okay. In this report, I will report about 2 works related to perovskite solar cells. Now let's say why I want to study perovskite solar cells. In the left picture, you can see the global energy consumption grows up in a short time, in just about 10 decades from 2015 to 2025. You can see the consumption comes up from 400 to 600. Okay, so it's a great deal. We can also see the oil price grows up a great deal as well. So there are a lot of causes for this problem we call energy crisis, such as overconsumption, overpopulation, poor infrastructure, energy waste, power plant commissioning delays, unused renewable options, and so on. So how to save energy and solve the problem of energy crisis is a big issue we humans need to face. Okay. In the second slide, you can see there are various kinds of energy sources, such as renewable energy, non-renewable energy. Okay. For renewable energy, we also call it green energy. It contains wind energy, hydropower energy, solar energy, geothermal energy, biomass energy, and so on. In this report, I focus on the solar energy because solar energy is plentiful and inexhaustible, and it's a kind of green energy. And so in the right side, you can see the US Energy Information Administration reports that the renewable energy becomes more and more important nowadays. Its consumption becomes larger and larger in the whole energy cost in US. I think this trend happens in all over the world. So I want to say renewable energy is a key for sustainable development of humans in the future. One way to solve the energy crisis I just said is about using solar energy. So later on, I will talk about the solar energy. For solar energy, in recent years, a kind of next generation solar cells, we call it metal halide perovskite solar cells, become famous. Why? One reason is that its cost is very low. The other is that its efficiency becomes higher and higher in just about 10 years time. So it develops very fast. We can see from the table, from the NIEL solar cell efficiency table, its efficiency rises from 3.8% in 2009 to 25.2% nowadays. A great deal, okay? The development of perovskite solar cells is very fast. Why? I think the main reason is because of the material itself. Perovskite has a lot of special characteristics, such as it has tunnable band gap from 1.2 to 2.3 EV. Okay, so it can absorb most of the sunlight. It has strong optical absorption range. Okay, and also this kind of material is tolerant to defects and green boundaries. So if the perovskite material is not as pure as we want, we can also fabricate perovskite solar cells with high efficiency. On the other hand, perovskite solar cells can be fabricated by a lot of ways. The most important methodology is through solution process. Solution processable with scalable manufacturing process can make perovskite solar cells commercialized in the future. We all think so. Okay, you can see the efficiency development in recent years. It rises very fast. There are three kinds of perovskite solar cells nowadays. One is what we call the mesoporous structure. The other two are what we call the conventional structure and inverted structure. In my research, I focus on the inverted perovskite solar cells. There are a lot of deposition methods of perovskite in perovskite solar cells. For large-scale fabrication, we use one-step deposition. For lab-scale fabrication process, we use one-step deposition method or two-step deposition method. For large-scale fabrication in factory, we use blade coating, slot die coating, spray coating, inkjet coating, or screen coating, or what we call the screen printing or roll-to-roll process. Okay, so this research may be very famous, but there are a lot of issues to be solved until now. One issue is about how to further improve the efficiency of Pscs. And we can see in the right picture, perovskite solar cells has got a high efficiency nowadays, but we think that its theoretical limit is about 30%, 25.2 versus 30. I think there's a long way to go. Okay, so the most important methodology nowadays is minimizing the voltage loss in this kind of solar cells. How to achieve this? One way is to make all the materials with excellent energy alignment. The other way, I think so, we can use better hole transport materials or electron transport materials and so on. Okay. The second issue nowadays we need to solve is about its instability. As we all know, perovskite solar cells is easily to be decomposed in air because perovskite has a lot of traps and defects inside, and also the ions in perovskite can be easily moved. Okay, we call it ion immigration, and also high temperature, electric field, light or moisture can affect the stability of perovskite. So we can see these chemical equations here. Perovskite itself can be decomposed very easily. Okay, so how to solve this problem of instability is a bottleneck for the commercialization of perovskite solar cells in the future. Now I will talk about my recent two works about perovskite solar cells. Work one is about I developed a kind of new material as hole transport material in perovskite solar cells. As we all know, there are a lot of hole transport materials in perovskite solar cells, such as the famous spirometad or PTAA. These two materials we are very familiar with. Okay, but these two materials are not easily to be synthesized. It has a lot of it needs a lot of cost. Okay, so how to develop a kind of hole transport material to replace spirometad or PTAA to fabricate conventional perovskite solar cells? This is my study purpose. Okay, so at first I compared the spirometad with PTAA. We can see the chemical structure. There's the same component in these two chemical structures. We call it TCTA. This kind of component is very important. Okay, so from this point on, I think if we can combine the advantage of PTA and the advantage of spirometad together, can I design a new kind of material which also shows good mobility and good hole transport ability and good morphology as spirometers or PTA. So I want to try. And first, I designed this kind of material. We call it M1. This material has a core. We call it DTBI. The second step, I changed this part from this very small unit to this very big unit. Okay, this is the second step. For the third step, I replace the core of M2 from DTBI to PTI in M3. So one step, second step, and the third step. And finally, I got M1, M2, and M3. The detailed synthesis process is shown on the right side. You can see here. So finally, I got M1, M2, and M3. So the next step, I measured the characteristics of M1, M2, and M3. For example, the hydrogen NMR, HRMS, absorption, TGA, band levels. Okay, and finally, I found that compared with M1 and M2, M2 shows compared with M1 and M3, M2 shows better thermal stability, which can be shown from the TGA picture, okay, here. And also we can see for energy alignment, we can see M2 has better, exhibits better energy alignment than M1 and M3. So holes can be much more easier to be extracted from perovskite to M2 than M1 and M3. When compare M1, M2, M3 with spirometers, we can see that for M1, M2, and M3, holes transportability is worse than spirometer. Okay, so I guess maybe my device efficiency is lower than spirometer. Okay, from this picture. Okay, from the absorption spectrum, we can also see that M2 shows stronger light absorption than M1 and M3. So later on, I fabricated perovskite solar cells with a conventional structure by using M1, M2, and M3 to replace spirometers. And finally, we found that devices with M2 as whole transport material shows efficiency higher than 16%, while for M1 and M3, the efficiency is much lower. When compared with spirometers, we can also see that the M2-based devices show similar efficiency compared to those with spirometers. And also our fabrication process shows good reproducibility. We can see from the SEM image, M2 shows a much more flat morphology, but M3 has a lot of pinholes. When compare M2 with spirometers, we can see maybe the spirometer has a much mesoporous or what we said better morphology than M2. Okay, so maybe why spirometer has higher or shows higher efficiency than M2-based devices? It has better morphology. Okay. So at the last, we measured the stability of my devices. We found that M2-based devices shows better long-term stability than M1 and M3-based devices. And also when compared with spirometers, M1, M2, and M3 shows higher, much higher long-term stability than what we use spirometers. Okay. This may be caused by the contact angle. We can see here, for M2, it has the biggest, or what we can say, it shows the largest contact angle, much larger than spirometers. So water cannot be easily come into perovskite layer, because M1 or M2 or M3 here as HTM can be a kind of protection of perovskite, okay? We also compare the synthesis cost of M1, M2, M3 with spirometide. We can see that all these materials are cheaper than spirometide, especially for M2. It shows good efficiency as well as spirometide, and also enhanced long-term stability than spirometide, and also reduced synthesis cost than spirometide. So my topic here is that, my theme, okay, is that M2 is a star molecule which can be used to work as HTM in NIP perovskite solar cells. Okay, we also measured the mobilities of M1, M2, and M3. We can see that M2 shows higher mobility than the other two. For peer and the TR peer spectrum, we can see that holes can be much more easily transported from perovskite to M2 than M1 and M3. So M1 and M3 shows a lower hose extraction ability than M2. So M2 may be the best choice in this research, okay? So my conclusion is that 3 novel dopant-free hole transport materials are studied in this research as expected, containing DTBI and core, and this slide I just showed, okay, this part, the big unit, okay, and the component. M2 shows higher hole mobility, better film forming morphology, and photovoltaic performance than M3 and M1. And the result, dopant-free perovskite solar cells with M2 shows PCE of 16.9%, as well, which can be compared to spirometide-based ones, and also with low cost and enhanced long-term stability. So based on work 1, I conducted work 2. Does M2 only is M2 only HTM in perovskite solar cells? Maybe it has other kind of functions in perovskite solar cells. For example, can it be a kind of interlayer? So this is my topic. Improve the hose extraction of PTA perovskite with an organic surface modification layer. Here, I want to use M2 as surface modification layer in inverted perovskite solar cells. Why I want to study this topic? There are 2 main problems in inverted perovskite solar cells. One problem is that the low crystallinity of perovskite. So after years of study, interfacial engineering may be the key to solve this problem. From this review, you can see here, from this review, we can see that by surface engineering, there are a lot of ways, and there are a lot of interfaces in a perovskite structure. Okay, you can see here, how to modify these interfaces to increase or enhance the crystallinity of perovskite is a key to reach high efficiency, okay? Another problem is that PTA is a good material, but it has low hose extraction than spirometide. So until now, the efficiency of conventional perovskite solar cells is still higher than inverted structures. Inverted perovskite solar cells shows lower efficiency than conventional structures. So a lot of researchers modify the structure of PTA to get higher efficiency, while others use doping method. They doped a lot of N-type molecules into PTA to get high efficiency. And in my research, I just want to use surface engineering here to enhance the hose extraction ability of PTA to reach higher efficiency. So how to solve these two problems? Get highly crystallized perovskite and use use PTA with higher hose extraction ability. Okay. In my research, I still use M2 here, but M2 this time, M2 is used as surface modification of PTA to replace PTAA in this kind of inverted perovskite solar cells. We can say the energy level of PTA M2 is very strange, okay? The LUMO is lower than PTA and the HOMO is similar to PTA. So here, holes can be much more easily to be extracted from perovskite to PTA M2 than PTA because energy band gap is lower here, okay? This is just a theoretical analysis, okay? Later on, I just conducted PL measurement and time resolved photoluminescence measurement. And finally, we found that our prediction is right, okay? The hose extraction ability of PTA M2 is much stronger than PTA itself. Okay, so our surface modification here enhanced the hose extraction ability of PTA. Okay, because M2 is very, very thin layer here. And the other function here, we can say in this picture, the grain size of perovskite on PTA M2 is much larger than PTA perovskite. And also in XRD spectrum, we can see that PTA-based perovskite and PTA M2-based perovskite, they are different. Okay, the XRD peaks becomes much more, much sharper here for PTA M2-based perovskite than PTA-based perovskite, okay? So another function here is that through surface modification of PTA use M2 here, the crystallinity of perovskite becomes better, okay? Later on, based on the above basic characterizations of perovskite and whole transport materials, we fabricated devices using M2 as interlayer, or what we call surface modification of PTA here. And finally, we found that devices with M2 as certification, as surface modification shows less hysteresis and higher efficiency than those without M2. And also, we fabricated 24 devices for PTA-based ones, and the other 22 for PTA M2-based ones. We can find that our devices with M2 and surface modification shows much better reproducibility here. Okay. For light stability, we measured the light stability of PTA-based devices and PTA M2-based devices. We can see that the photo stability of inverted perovskite solar cell with M2 is much stronger than PTA itself without M2. Okay. So my conclusion here is that using M2 combined with PTA as a composite hole transport material facilitates the hose extraction ability with a more appropriate energy level alignment for inverted perovskite solar cells. As a result, this kind of solar cell based on PTM2 composite hose transport material shows enhanced efficiency from 18.7% to 20.2% due to the enhanced crystallinity of perovskite and improved hose extraction ability of PTA itself. So I think in the future, maybe more works should be done to explore whether M2 can be doped or M2 can be developed into other kinds of hose transport material, which shows even higher hose extraction ability and hose transport ability. Okay, that's all for today. Today's report. Okay, thanks for all the professors and collaborators, which gave me a lot of support. Okay, welcome to my university, University of Macau. Welcome everyone to have a visit. This slide just shows a beautiful picture here, you can see. That's all. Thanks for your attention and support. Anyone want to ask questions about my research? Welcome.
Good evening. Yeah, thank you so much for providing such an opportunity. So it gives me a great pleasure for me to extend my wishes to all the participants. So the today topic, can I share my screen? Visible?
Yes.
Yeah. So good evening, one and all. So today topic is IoT development opportunities and challenges. So according to India Internet of Things market forecast and opportunities 2020, IoT market in India is projected to grow at a CAGR over 28% during 2015 to 2020. So the IoT is being rapidly brought into use across the diverse industry verticals to reduce the operational and manpower cost and increase the operational efficiency also. So the consumer electronics like the automotive transportation, banking, financial services and insurance like BFSI, home and building, energy and utilities, retail and supply chain and logistics sectors, and manufacturing are the key emerging applications areas where the IoT technology is majorly being adopted. However, India's IoT market is highly fragmented with numerous players operating costs across the value chain. So with the growing need for connectivity among devices, systems, and even services using variety of protocol and domains, automating business processes, and real-time monitoring and tracking of services and systems. So the IoT technology has been gaining increasing market transaction over the last few years. So in the IoT concept, the things can be any natural or any man-made object that can be assigned an IP address and provided an ability to transfer the data over a network. So with this short introduction, just I start my session. So the overview of today's session, the outline started with the overview of IoT. What are the opportunities? What are the IoT opportunities? And what are the research challenges based on IoT? What are the key digital trends shaping the future of IoT? And finally end up with the question and answer. So the overview of IoT, whenever we are talking about the IoT, just imagine waking up in the morning at the sound of your alarm clock and your coffee maker automatically prepares your coffee. So, and also how about your refrigerator is sending a shopping list of items that you need to refill, such as some eggs are only 2 eggs are remaining, and the milk quantity is very low like that. So these are the things. These are the very interesting things whenever we are talking about the IoT. So at the same time, whenever we actually started about the GPS. So the maps have taken the passenger seat at as a GPS, and it take the driver seats like that. So that is a very important thing. And here, the term Internet of People and Internet of Things, that is a very, very important thing. Actually, before the Internet of Things, we are talking about the Internet of People. So the term Internet of People has been used before that IoT, but usually it referred to the traditional web systems. It's designed only for human to use. Here, we use in the sense of bringing the IoT somewhat closer to people for them to easily integrate into it and fully exploit its benefits like that. So the internet's available. So the both Internet of People and Internet of Things. Here, the internet is very, very important thing. So the internet's availability almost everywhere has that favor the emergence of countless devices equipped with their connecting interfaces. So linking these the devices and other everyday that physical objects to that internet is getting ever easier. So enhancing the popularity of the Internet of Things. That's right. So the one primary goal behind such kind of smart integration of devices is to simplify the people's living habit or living style by having the technology work for them seamlessly. So for instance, for example, we may say you can remotely switch on your house home's air conditioning system using your smartphone to get a comfortable temperature when you are arriving home like that. So the even for nowadays we are having the smart mirror. So with the help of that mirror, everyday routine can be integrated in that mirror itself. So that is a very, very important. That's why that whenever the Internet of Things, the Internet of People and Internet of Things is very, very important thing. So next thing is here the Internet of People and Internet of Things. Here the T is a things. That is a T stands for things in the Internet of Things IoT. Here the things are the object of the physical world of the information world. It's a like virtual world. And here the things are capable of being identified and integrated into the some communication layer. And another very important thing, the things may be a physical things. So in that physical thing, it may be a surroundings, environment, sensors, any kind of electrical equipment, etc. So the list is going on like that. That is a physical thing. Whenever we are coming up the virtual things are capable of being stored, processed, and accessed that information. The information may be any kind of media. That is, it may be a multimedia content, a Facebook data, Twitter, some other things. So that is a very important thing. So whenever we are talking about that, what the Internet of things, it can be actually the history started with 1990s. So the 1990s, just we are connected with the people. That is the internet is connected with the people. So the hundreds of million people are connected. In 2000, some billion people connected. In 2010, then more than billion people are connected. And in 2020, 10 billion of people are connected with the Internet of Things. So that is the very important thing. So whenever that introduction, whenever the Internet of Things, here the IoT is a system of its interconnected digital and both mechanical devices. So it objects are people that are given in the several unique identifier. That is a unique identifier maybe in terms of that IP addresses like that. So here it's mainly it's meant for ability to share the data over a network without needing the help of human to human or human to computer interactions like that. So that is a very important. That is the introduction about the IoT. So what are the smart world of IoT? See, whenever we are talking about the IoT, it's a very important thing. Actually, nowadays we actually all the way we are speaking about the smart world. So the smart city, smart car, like that. So whenever we are talking about the smart world of IoT, here the four important level of smartness is very important. The first one is the passive level. So the passive level it's nothing but it's a communicate only when queried. Like example, passive RFID, QR codes like that. And second important level of smartness is the active smart. So the active smart means the sense it's nothing but it communicate when needed. Example, some kind of sensors or the example maybe is in home automation like that. And third important thing is it's aware. So the aware is also one smartness category. So here mainly it's action based on the simple computation. Example, nowadays we are talking about the telehealth. So the telehealth is a fifth sense. Actually, whenever the aware smartness, it's using the fifth sense. So that is a best example for the awareness is aware smartness is the telehealth. And fourth important thing, autonomous. So all the way we are talking about the autonomous, that is it can make the decisions based on the rule. So what are the rules we provided? So based on that rule, that decisions are provided. So example, autonomous car or smart grid, like that. So here that is autonomous, it's based on that human things like that. So that's why the smart world of IoT, the smartness in 4 categories, the different categories are there. So these objects are embedded with the sensors, some sort of electronics, and software, actuators, and network connectivity that give them to the ability to exchange the data like that. So that is very important. And how does this impact you? How this that IoT system can impact you? So in that cases, the new rule for the future is going to be anything that can be connected and will be connected. So with the help of that, already some systems are connected, but some system will be connected to be connected. So based on that, that impact will be created. So based on that, why on earth would you want so many connected devices talking to each other like that? So nowadays we are in the IoT world. So everywhere, everything is connected through that system, through that smartness, through that internet like that. So in that cases, all the way we need some connected devices. That's why just we have to how you want you how actually would you want so many connected devices and talking to each other like that. So in that cases, it may be in terms of communication, control and automation, cost savings like that. So that is the very important thing. And next, opportunities. So what are the different opportunities are there? So whenever we are talking about the opportunity is the first opportunity. It's a looming opportunity. It's based on that. It may be in terms of the consumer. Yeah, it's a retail system, medical emergency system, military oriented application, industrial application, automotive system, environmental system, agriculture system, like that. So like that, this opportunity is going on. So here all the way, so already I told you that IoT system is very useful for all related application like consumer to agriculture like that. So the first one is the smart home or smart intelligence, smart home, intelligent home. So as per the smart home here, a home where the devices are enabled to communicate with each other, the making is owner capable of customizing their home environment and managing the security. That is also very important. So providing this all the way, the providing the security and also the energy that is known as the smart home. So here, whenever we are talking about the smart home, here various IoT technologies are responsible for monitoring these kind of smart homes. So the devices like smart thermostats, smart home lighting system like that. So for example, some of the things we are using the remote monitoring or remote control for the controlling all the appliances, all the home appliances. For another very important thing for the safety purpose. So when we want to open the door and close the door, so that kind of information also provided in that smart home or intelligent home. And another very important thing, energy management. So how we are utilizing the energy. So whenever we don't want the lights and fan, then automatically this system, the smart home system, it will turn off the lights and the AC like that. And another very important thing, the maintenance is also very important. Why? Because all the way, whenever in that home system, the pipes or the sinks are somewhat leaking. So that kind of leaking, that whether it will be working properly or not. So that kind of things will be monitored with the help of the smart home system. And even another very important thing, the entertainment system. So the entertainment control, that also done by the smart home system. So that is a very, very important thing. So the primary idea behind this intelligent home or smart home is we are all the way, we are efficiently using the energy management, energy and the maintenance things, and another important thing, safety also. And the next second, the application is a futuristic application, so mainly for the shopping. So whenever actually nowadays we are having the automated shopping systems are there. Just whenever we are entering the doors, the first point, when that she that enters the doors, and scanner will identify the tags on her clothing. So the clothing itself, the tagging is there. So the tag will be identify her details, all the details. And the second thing, when actually shopping in the market, the goods will introduce themselves. Actually, what about the see, nowadays we want to check the goods quality and expiry date and rate and other things. But here, this smart shopping system, whenever the particular person, whenever he entered into that shopping area, shopping in that market, the goods itself, it will introduce themselves about the rate, about the when it's arrived, and what about the expiry date, and every details are available in that itself. So that is another very important. That is a smart shopping. And third thing, when she paying the amount for that goods, and the microchip of the credit card will communicate with the checkout reader like that. So automatically, whenever he taken that item, automatically it will that credit card will communicate with the checkout reader. And next, finally, when she or he moving the goods, the reader will tell the staff to put a new one like that. So that is a very important thing. So automatic, it's a smart shopping system. It's a very important thing. And third important application, that is the opportunity is nothing but this is in the healthcare domain. So whenever the healthcare domain in the sphere of healthcare, the advent of the IoT is a major importance. So with the various smart devices, it's monitored by IoT, such as the medication dispensing services. Somewhat it's easier to carry out that worker faster in the field of medical emergency and the medical care system like that. So here, as per the global IoT healthcare market, it's expected to grow from 30 to approximately the 30 to $1 billion in 2015, and it's to that 165 billion in 2020 like that. So in that case, it's very important in the healthcare. Some of the applications or some of the tasks will be carried out in that healthcare system. That is like a remote patient monitoring services, mobile health technology, telemedicine and medication system, improved clinical care, employee workflow management, and inpatient monitoring like that. So all the way, even for the healthcare, in the healthcare system, the IoT is majorly it's applied in all the services, from the patient caring into that clinical care and everything that under the smart healthcare like that. And the next fourth application is a transportation. See, whenever we are talking about the IoT in the transportation, the IoT plays a very significant or very vital role in the automotive industry. Why? Because the rate of the IoT adoption in the transportation and logistic industry is already high, and it keeps accelerating. So the investing in new technologies, transportation companies lower the cost of shipping or transporting and increase their operational efficiency like that. So the latest trends in IoT, the transforming the way the people and goods are transported, like the predictive diagnostics and vehicle maintenance, also based on the automotive IoT system. Even for the nowadays, we are using the real-time cargo monitoring. So all the way we are from the home itself, easily we can monitor our actually that items, whether when it will be reached to our home like that. So everything, even the vehicle to vehicle communication and everything will be happening with the help of these things. So that is a very important application in the transportations. And IoT research challenges. So what are the, even whenever we are having the advantages, even though we are having some drawbacks, so the IoT research challenges, some of the challenges are there. The first one is the IoT is complex. So the IoT is complex in the sense is nothing but here the IoT is the Internet of Things is considered to be pretty complex. Why? Because, however, as a system is primarily related to making life somewhat easier, but it should be user friendly and not just easy for the developers and as well as the experts. So that is what in that aspect only the IoT system is somewhat complex. So that is a one challenge. And next challenge is a connectivity. See, whenever we are talking about the Internet of Things, IoT, the internet connectivity is very important, but the connectivity is crucial in some countries. So at present, we are using actually the various wired and wireless forms of connectivity are required to enable the proper functioning of the applications monitored by IoT. So that is somewhere missing. Somewhere actually we are lagging in that connectivity issues. So that is a second challenge. But nowadays, with the help of that network, so the 5G, 6G network, easily we can all the way we overcome that one. But even though somewhere something the connectivity issues are there. And third thing is a high power, that highly power consuming. See, highly power consuming is nothing but all the way whenever the IoT system, without power, there is no IoT. For the proper functioning of IoT, the technology and connectivity, here the power consumption is very vital and it's a very important thing. So that is these are some of the challenges. And apart from that, we are having some kind of technological standardization that in most areas are still remain fragmented like that. So that is also next challenges. And another thing, the managing and fostering the rapid innovation is a challenge for governments like that. So another next challenge is for the in terms of the privacy. Is it safe? Can the Internet of Things be secured like that? So whenever we are talking about the challenges in terms of privacy, whether the Internet of Things is secure or not. So everything new and shiny has some downside, like, and security and privacy are the biggest challenges of IoT. Here, why? Because here all the devices and system, it collects a lot of personal data about the people, about the things, about it like that. So that smart meter knows when you are at home and what electronic devices you are using and when you are there, and it started with other devices and held in a database by the company. So that will be, if suppose if it's a misunderstood or misconfigured, in that cases that IoT possesses a risk to data, privacy, and even for safety also. But if you understood and it's a secured, then the IoT will enhance the communications, lifestyle, and the delivery of the services in very better manner. So that's why the challenge, the very important challenge in the IoT is the based on the privacy. That is whether the IoT system is secured like that. So if we are using it appropriate manner, then it will be secured things like that. So next one, what are the key digital trends shaping the future? So in this case, actually, it's relying on this, based on that list, I would like to discuss in a little more detail the IoT trends for the human augmentation, the rise of security concern, practical blockchain, artificial intelligence, and the increase in the enterprise spending of IoT, 5G network, and the empowered edge like that. So that is the key trends in the shaping the future. And the first one is the power of connectivity and IoT's growth. So the power of connectivity and IoT growth is nothing but here the most significant IoT trend for 2020 and upcoming year is that the IoT networks of connected devices that the people are interacting with are going to extend, and the amount of data that can one gather from these networks that will increase too like that. So we have deliberately adopted a new lifestyles of being connected all the time. So this is evidently impossible to ignore, and the IoT industry is meeting us halfway life only. So based on the Gartner, actually the Gartner actually labeled his trend as a human augmentation. So not only the human connection, but also the university connected universally that are connected. All the devices are a factor that can make the difference in everyday experiences like that. So that's why that is a very important thing. So as a result, so more connected devices, there are actually the more consumer data is being collected, and this makes the entrepreneur is responsible of creating and getting the compliant with the some security policies like that. So next, the IoT security trends. It's raising the security concern on the table. So whenever that connectivity, the tangible of the connections is bound to unwrap the some network security, it challenges in the Internet of Things future. But some connectivity solutions like Wi-Fi are not reliable enough. Besides, the network running these devices are highly vulnerable due to their fragmented nature. So this issue is getting ever more pressing in 2019, and thus introduced another Internet of Things trend that needs a addressing like that. So that's a very second thing. And third thing is a blockchain technologies. It's shaping the future of IoT. So here, the blockchain is one of the key IoT technology trends as for today. So the exchange of money and the data between the IoT devices is in a reliable manner or in a reliable way is becoming possible once the blockchain technology provides them with a simple infrastructure for doing so like that. So put together these two phenomena, IoT and blockchain, are living up to their hype like that. So the fragmented nature of IoT that matches this decentralized nature of blockchain. So the latter offers that anonymity and security to multiple networks and their owners, while the digital signatures and the private keys, it's following each transaction's guarantee that the IoT environment will be safe. So like that. So whenever we are talking about the blockchain technology that's shaping the future of IoT, in the sense here, the IoT devices are designed to make a life of a person or an operating and until whenever it will be easier and whenever it will be a more fast manner like that. So this requires a constant generation of the personal data and implies more considerable risk of that hacker attacks like that. So next, the fourth one, we are using the 5G network it across the industries. So the 5G network, 5G network in 2020 and 2021 will continue to be deployed across the different industries around the globe, but it will be contributing the factor driving an increase in the number of IoT devices. So 5G as well as the Internet of Things are are considered the beacons of the fourth industrial revolution that is still going in 2020 and 2021 like that. So together of IoT and 5G are establishing an infrastructure for smartphone and tablet and as well as the wearable and some medical devices like that. So the fifth one is the empowering edge computing in IoT. So empowered that edge computing in IoT, in that cases, the edge computing is definitely one of the key industrial IoT trends in 2020. So here, the edge node and gateways connected to IoT devices and systems that help them reach the various type of data centers. So the IoT data often has to travel long distances from the data center to the device, yet empowered by the edge technology, edge computing technology, it will less likely experience the low bandwidth or increase in latency like that. So that is a thing. So here in 2020, the pair of technology is moving to the forefront. So the final thought, the world of IoT has a true potential for the development as it makes life easier through the various innovations which are developing and will develop in the future. And the functioning is impossible without IoT technologies monitoring. So IoT is not implemented in one go. It is an incremental process that gives an incentive to nearly universal digital transformations. So the IoT Trends 2020 promises to put a spotlight on in both the consumer and industrial field. It proved that the future has already begun and the technology will keep that changing their lives or changing our lives. So you are inevitably going to face some challenges. Thus, to successfully adjust the business processes to the new capabilities, you should get an in-depth understanding of the IoT latest trends and the hurdles they may entail first. So then it will be easier for you to address those difficulties and challenges. So the extracting and maximizing the value from it, from this knowledge like that. So with this short note, this I will conclude my session. Thank you so much. So any query?
Our next speaker is Dr. Baswara Jaya from Karnataka Veterinary Animal and Fisheries Science University, India. He is going to give a presentation on study of anxiety and fear of COVID-19 pandemic in Indian context. And I request Dr. Baswara Jaya to start his presentation.
Study of fear of COVID-19 in Indian context. Yes, all of you should aware of that the COVID-19, it is a pandemic crisis. We have suffered a lot from 2020 to till date. That is, it is a scourge. That is a pandemic. It's a scourge. Nearly, it's a deadly disease. Nearly affected 3.50 populations. World populations have suffered and also threatened by the COVID-19. In the Indian context, moreover, that is the May and June month, that is the growth, the infection growth has been exponentially increases for a period of time, that is a drastically decreases. The pandemic crisis, the epidemic deviation has been taken place by the COVID-19. Yes, my topic is a very interesting topic. Yes, all of you should experience the anxiety and fear of COVID-19. Yes, the mode of transmission is aware of that. That is a direct contact and also indirect contact. Then the direct contact is a droplet of infection. Then contact with soil. Anyhow, that is some agriculture and field experimentations. Then we have catch the virus, then contact with soil and the inoculations into the skin with mucosa. Then a vertical transmission has been arose. Say, for example, mother to child transmissions also it come across the COVID-19. Then indirect, the vehicle borne, vector borne, and airborne. Then fumit borne and also unclean hands and fingers. That is, these are all these indirect mode of transmission of HIV. That is the COVID. Then the COVID-19 progressions, the exposure to the virus. Any persons then has been exposed to virus, the incubation period is very important. Nowadays the incubation period of virus, that is 4 to 6 days or 14 days. That is upstream data. Then it incubates. It depends upon the body conditions of the patients. The WHO has been inculcate the incubation period. It is upstreaming data. Then the persons develop symptoms. That is after 4 hours, after 4 to 5 hours, the incubation period. Within the 2 days, the symptoms has been aroused. The infectious period, that is 8 to 10 days. That is a maximum period is 8 to 10 days, but can be longer, up to 1 to 3 days before symptoms it can develop. The illness will start days, but in longer days we can be penetrated. Then after 10 days, when the person has been cured or in some infections has been reduced for a period of time, then when the person has been taking treatment or some other the viral treatment, etc. So no more symptoms, then the release from the isolations. Yes, this is the one of the interventions of the progression of the COVID. Then the legacy of infectious disease. There is a legacy is very important. Yes, the human populations has experienced so many pandemic crises from that is first century to till date we have experienced. Over 100 years, the infectious that becomes a epidemic, then it becomes the pandemic crisis. Then a first pandemic is liver brine amoeba. Then that is up to Spanish flu, COVID-19, cholera, Indian wool fever, typhoid. Then the black plague, that is nearly 1.86 million of the populations has been died during the black plague as compared with COVID. That is a black plague is a very very dangerous pandemic experienced by the people. Then the millennia, that is that is how the millennia takes place. That is a 2020 liver brain amoeba, that is a 20th century. Then again that is 100 years, over 100 years the century. Then one or other way, that is this virus has been attacked and also that leads to pandemic. That is a 1920 Spanish flu, then 1820 cholera, then 1720 Indian wool fever, then 1620 typhoid, then 1520 Ron syndrome, then black plague. These are all these millennia with respect to the pandemic crisis. Then the symptoms of COVID. Then the COVID symptoms is one is the common symptoms and also the two that's a rare symptoms. The common symptoms of first infections itself, so that is that affect T cells or CCR5 or the dendrophage. Then it enter the spike protein. then the virus has been little bit of then exhibit the common symptoms, that is a fever and cough like symptoms. Then it will penetrate, and also that is again that pneumonia like symptoms. Okay, then cough, high fever, throat infections, these are all these common symptoms. Then the rare symptoms, that is headache, then sore throat, and hypoxia, then the muscle pain, then ERDS, acute respiratory distress syndrome, then sepsis shock, then there is a edema has been aroused in that particular organs, internal organs. Then the multiple organ failure, that is one of the instances we have seen in that particular COVID patients. Then the secondary infections also aroused, that is say for example opportunistic infections, black fungus and also white fungus, the yellow fungus. This is the secondary infections after that patients has been discharged from the hospital, then the secondary symptoms has been aroused. This is the commonest, and also the rare symptoms have been noticed in the COVID patients. Then the infected patient after postpartum findings, we have seen the lung, there is a 100% lung orientations has been lost, that is a primary lobe, secondary lobe, and tertiary lobe. Even halvea also, that is has been destroyed by this virus. It is a deadly virus. It is, I will tell you, it is a deadly virus. Please be concentrate on that particular social distancing, and also some other prevention strategies you have to maintain. We should not ignore, because this is the pandemic virus that can penetrate anywhere. That is that can lead to multiple organ failure also. Then the infections with respect to the death rate, that is a CFR, case fatality rate, that is 80 years, 80 plus, that is a geriatric populations 14.80, then 70 to 79 8%, then 6 to 69 3.6, 50 to 59 1.3, then 40 to 49.40. Then this death rate has been varied with respect to different geographical locations also. In Indian conditions, that is 60 to 69 and also 50 to 59. Even inclusion with the younger age population also has been died due to COVID crisis. Okay, then the male CFR is 2.80, then female is 1.71. It is significantly associated with the male and female. There is no significant differences. The male is predominantly suffered from the the COVID-19. Please conscious about the male population. Then coming to the perception, our topic perception is the fear and COVID anxiety. What is meant by the fear? The fear is a normal reaction to a known. Okay, the fear is a normal reactions to a known. It is that is the the population has been experienced the fear. But say for example, external sources of danger, it comes under the phobia or a normal reactions. That is a fear is the external source of danger. Then it comes to the phobia or normal reactions. Then the anxiety, that is an individual, it is a frightened, but a source of danger is not known. The source of danger is not known, but it is a recognizable. Some we have recognized, say the COVID is a threatened disease. It has been penetrated in any way. Okay, there is so many patients or so many populations has been, that is fear and phobia is a direct and indirectly approach to the that particular populations. Then inadequate to known account for the symptoms, say for example psychological manifestations. Then the quality life of entire populations has been declined due to the phobia and anxiety. Here, that is Indian context, that is around the COVID induced death or mortality is very less when compared to the other population. Say that is a phobia and fear or anxiety, the case fatality rate is increases, because say for example the person has been suffered from phobia or anxiety, there is a sudden death we have been seen in that particular populations. Then phobia, it is a persistent unrealistic. Okay, that is a persistent, it is a relative persistent and also unrealistic phenomena. In the intense of fear or specific stimulus has been arose from that kind of populations, it leads to the unavoidable circumstances. Okay, that is the phobia. Then the phobia has been classified into the two groups. One is the specific phobia and the social phobia. This is the specific phobia. This is an intense irrational fear of a specific trigger. Okay, the specific domain has been correlated with respect to the specific phobia. Then the social phobia, this is a profound fear of public or humiliations. Okay, somehow that is a public or some TV media or some other gadgets. They have shared the unrealistic informations, COVID informations to the your phone or gadgets. This realistically this increases the phobia. That is a social phobia. That is a social phobia is the one of the indicatoral phobia to increase the mortality of the patients as well as the general population. Then fear, it's a stress response from the immediate danger. Then anxiety, what if the big bad? Okay, yes, this is a stress response just from your thoughts. Okay, the anxiety, it is arose from your thoughts only. Then the expected effect, that is a phobia and also anxiety. That is, it will affect the direct and also indirect effect. Then the direct effect is the depressions and also the existing psychotic symptoms, increases in alcohol or misuse of other addictions, educational impact, and also some depressions. Okay, these are all these short-term effect. Then the medium or long-term effect, bereavement, psychological impact on frontline staff. Then the actual economic impact, somehow this is due to pandemic crisis. So many populations have been lost. There is a that is a employment. There is a that is a suffer from the economic crisis. There are insecurity for the livelihood. Then income reductions, increased debt or housing loss or loss of socioeconomic status. These are all these medium and long-term effect. Then these are all adversely affect the populations to increase the phobia or anxiety. Then the high functioning of anxiety, yes, this is the very important. Our feel is very important. So, for example, when we will experience helpful, then you have to experience something will go wrong if I don't know everything myself. It is a feel, that is our feel. Then organizational impact, my mind is frequently jumps to the worst case scenario and I feel out of the control. I am not prepared. So, for example, in case of surge of COVID second wave, that is May and July month. Yes, it is a drastically, that is so many patients has been suffered hypoxic stages, and also that is death has been that is a danger mode. Yes, we have experienced that particular instances, the case scenario. I feel out of the control. So many patients is out of the control. They can die and also they can suffer from these deadly diseases. Then the hardworking. I am not naturally talented or intelligent, so I need to work harder than everyone else. This is hardworking criteria. Then detail oriented. I'm fearful of being blamed and criticized if I make even the smallest mistake. Even smallest mistake also, that is a magnifying they know that is a large mistakes. Then the S persons, if I know I will be letting people down. The self-sufficient, if I ask for help, people will think I am not a good enough. Yes, I don't know about these things. The self-sufficient has been declined, that particular anxiety. Then the active, I don't know about switch off and relax without feelings. It is the relaxation is very difficult in terms of anxiety. The confident level also, they just come down. Then the symptoms of anxiety of COVID. Yes, that is a major symptoms. That is sweating. It is I think the 80% of the populations are sweating. Abnormal breathing. Then accelerated heartbeat. That is irregular heartbeat. Okay, the heartbeat is less than 90 beats per second. Then trembling. Then heart clusters or chills. Then the choking sensations, GERD symptoms. Gastroesophageal symptoms has been recorded, has been noticed. Then the chest pain or chest tightness. Then butterflies on the stomach. These are all these symptoms. Then dry mouth. It is 100% dry mouth. Then confusions, and it's more than 90% are confusions. Then nausea. Then the dizziness and headache. These are all these common symptoms has been enlisted with respect to the anxiety. Then how to affect the human body by fear and anxiety. Yes, so many organs has been penetrated and affected the anxiety. Then first one is a skin, the skin problem. So many is, dermatological complications has been arose, say for example, psoriasis, eczema, dermatitis, and also breakouts of the skin, that is a rashes. Then the stomach can cause peptic ulcer or diseases. Then the GERD, food allergies, some GERD reflux syndrome. Then weight fluctuations, that is in weight increases or decreases. Then the pancreas results in elevated secretions of insulin. Okay, the insulin level has been fluctuated over a period of time. Then cough due to the diabetes, then damaged criteria on are also the obesity. Then the persons will be suffering from the anxiety. The obesity is more than 30 kg per meter cube. Then immune system, almost immune system is destroyed. Okay, that is without proper treatment, the anxiety level destroy the entire human system. Then the head, the issues with the mood. Okay, the mood changing symptoms has been aroused. Then the anger and depressions, irritability syndrome, the lack of energy, concentrations, some concentration problems, and also panic attacks. Even small problems, the persons who are suffering from the anxiety, it may lead to the panic attacks. Then heart, increased blood pressures. Okay, there is dystolic and diastolic blood pressure also increases. The fast heartbeat. Okay, that is a 105 or 120 beats per minute heartbeat. Then increased risk of heart attack. Okay, that is one of the cardiovascular symptoms due to arose from the anxiety. Then intestine, decreased nutrient absorptions. Then the reduced metabolism syndromes also. Okay, MEBD also that causes from the anxiety. Then the reproductive symptoms. Yes, even sexual behavior also lost due to the reproductive systems. Then decreased testosterone, and then egg productions also decreases. Joints and muscle pains, inflammations. We have seen so many cases. Are there so many patients? The tensions and lower bone density. The bone density also decreases. Some kind of cause of osteoporosis and the tightness in the shoulders and back regions. Then the main importance of this study we have undertaken. First one is the rationality. The anxiety and fears will be increased in age and children populations, inclusion with pregnant women, and also the persons with underlying comorbid conditions. As for example, clinical conditions, the persons who are suffering from the diabetes, the persons suffering from the life-threatening diseases, the cancer, and also some other malignancy cases also, the anxiety will increases. Then during the COVID outbreak, the social media or platform, okay, say for example, the TV, WhatsApp, LinkedIn, etc., have become active sites. These sites are disseminated the informations or conspiracy theories. It is a negative conspiracy theories. Okay, it will affect the populations negatively with the mental status of the populations. The association of the individual beliefs. Third one, the association of individual beliefs in different conspiracy theories of COVID, mental health and well-being issues is very important. Yes, the quality life of population is declined over the period of that is a 2020 era. Then this issues is it's a challenging issues for health policymakers as well as the clinical persons or clinicians. Then this is the rationality. Then the very limited literature is available at worldwide for taking curative measures for exploring the health policy to mitigate the control measures of COVID-19 pandemic. Okay, this is the four rationality. Based on the four rationality, we have taken this research project. Then the objective of the interest in this paradigm of the rationality, the present research study attempt to explore the level of anxiety and fear of COVID in Indian context. Okay, then we have to assess the anxiety and also fear with respect to the Indian populations. Then the practical utility, the outcome of the research will be more beneficial for health policymakers, planners, epidemiologists, clinical psychologists, and healthcare professionals for taking right decisions with respect to the psychologically deprived population, especially with psychologically deprived populations. and also clinical underlying conditions, comorbid conditions. Okay, then this studies will be very useful for formulations of the health policies. Then methodology, the online survey was performed during the pandemic of COVID-19 using a non-probability snowball sampling techniques. Okay, that is one of the important methods we have been used. Then the questionnaires were validated and comprised the questionnaires as contains the demographic characteristics regarding fear and anxiety, as well as the fear scale has been used. FCV, that is a 19S, that is a new scale we have been used for the assessment of the populations. A total 650 respondents were selected from the database of social platform. We have randomly chosen the respondents from the total populations based on the proportional allocations method. We have categorized the respondents based on the demographic criteria and also the clinical criteria. As per the categorizations, the respondents were grouped as two. The first group called as a frontline healthcare workers, like medical doctors, dentists, nursing professionals, pharmacists, and also the second group is also considered the general public. Okay, that is the first group is frontline healthcare workers. The second group was the general public. The structured questionnaires was sent through email and electronic gadgets. Okay, the confidentiality 100% with the confidential maintained for the during the data collections. Okay, security password we have been maintained for data collections. Then there's an inclusion and exclusion criteria. Yes, the inclusion criteria say that is a less than children population. The the pediatric populations has been excluded from our studies, and also the people with the learning disabilities. Okay, the BAME. Then the older people, the parents, those who are not giving the information. Is unable to giving the information, that kind of populations we have been excluded. The people that are shielding, say for example children and young people with their interpersonal trauma, the population has been suffered from the trauma, then we have been excluded. Then the people with severe mental health conditions, say for example epilepsy patients and also other high risk populations of the mental disorder, then that population has been excluded. Then the people with ASD, then and ADHD, the substances abuse and also some other drug abuse, the population has been excluded. Then care home takers, living alone, the the populations living alone populations excluded. Then the people with pre-existing physical health conditions, family and people whose treatment pursued. Then the people suffering from domestic abuse. Okay, this kind of populations are excluded during the survey. Then the structured questionnaires format included open and closed-ended questionnaires. Okay, that is we have asked open and also the closed-ended questionnaires. For each questionnaires, different facets of questions, and also the it contains the 0 to 5 scales, the level of agreements on each statement or questions indicated by 5-point Likert scale. Okay, 0 to 5-point Likert scale has been considered for the data sets. Then the logistic regressions and ROC analysis, the receiver operating characteristics analysis was done at the greater accuracy for compilation of data sets. Then the cutoff value was calculated based on the sensitivity analysis. Okay, the level of agreement was tested by modified capacity. Okay, these are the method we have been adopted for the testing the hypothetical statement about the research. Then another inclusion criteria, some hierarchical basis, we have been included the qualitative informations also. The qualitative informations for that particular cross-sectional informations has been debugging from some other secondary source data sets. Okay, say for example editorial expert opinion, then case reports, cross-sectional studies, case control studies and cohort studies, and randomized controlled RCT trial also we have been considered for describing the overall well-being of the anxiety populations. Then this is the fear scale. That is a fear distributions with respect to the age group, different age group. Say for example, the age group it will start 20 to 25, then 26 to 30, then the 46 to 40, 46 to 50 years age group. Yes, the frontline healthcare workers less than 9 score and also more than 9 score Okay, Likert scale, the 0 to 10 scale, we have been enlisted for the data collections. Okay, then see, nearly that is a 36 and also 41 to 45 age group of the populations. Healthcare workers is a more suffering populations. These are all these the sufferer from the anxiety or the fearness, especially health care workers. In case of general population, yes, see that is again 50, that is a 36 to 40 years. Yes, this drastically the anxiety level increases, and also they're statistically significant at 1% level of significance. Okay, that is a general population. The mean age group of the population is 36 years, and the frontline healthcare workers, the mean age group of the population is 42.36 years. Okay, these are all these the frontline and also general populations. Then anxiety and phobia of COVID by confounding effect of watching TV and social media using week per day. Yes, see that is a 0 to 1 hours. Geometric mean score is a 1.25. For a period of time, that is the populations has been increases watching TV. The phobia and anxiety level also increases. See, 1 to 2 hours, 3 to 4 hours, 5 to 6 hours. More than 6 hours, the geometric mean has been decreases. Okay, so increases is 6.79, then 4.98. See, that is directly proportional to the social media and TV watching. Okay, the confidence level also increases. The boundary level of confidence also increases. The condition of the logistic probability value is significantly associated with the increasing the TV watching and social media. The level of anxiety and also the fearness also increases. Yes, the correlation of association between the different anxiety level has been correlated with binary least square analysis. Yes, this is the living status. See, that is a without family, with family. Yes, without family. Yes, and with family. Is both populations have been significantly correlated. Then employment status, the comorbidity, smoking, alcoholic status, then increases drinking last 4 weeks. Then these are all these sachets, the sleeping and also coping factors, then underweight, overweight, eating behavior, then eat less health. These are all these significantly associated with the COVID, irrespective of all the parameter, the COVID anxiety level has been increases. Then the convergent of the validity fairness effect of the SEF, the COVID scale, based on the COVID scale. Yes, that is a hard ratios, and based on the hard ratios, we have been correlated. I am most afraid of COVID. Yes, the hard ratio is more than 1%. It's a 5.62. It's strongly correlated. It makes me uncomfortable to think about COVID. Yes, 3.55. My hands become clammy when I think about COVID, 8.74. Then I am afraid of losing my life because of COVID-19, 6.28. When watching news and stories about COVID-19, social media, I become nervous. Yes, 10.25. Then I cannot sleep because I am worrying about getting COVID, 4.98. My heart races, palpates when I think about getting COVID-19. Yes, that is a 1 point. All the parameters, the convergent parameter is significantly associated to increase the COVID fearness and the anxiety. Yes, the quality life of quality domain also correlated with respect to anxiety. Yes, the quality of life domain, physical level of independence, and also physical level of independence, as psychological impact. Yes, all is less than 50 or less than 25. Okay, the quality of life mean score is drastically decreases when the person is suffering from the anxiety, COVID anxiety. Then with respect to the general characteristics, yes, the general characteristics, yes, general hygiene is very important for well-being of the populations. Yes, frequency wash hands with soap and soap at least 10 minutes. Yes, it is the anxiety level has been declined. Then less than 30 minutes is 6.22%, 30 to 60 minutes, 80.78. Okay. Yes, 30 to 60 minutes. That is the highest percentage expressions was being found in that particular populations. More than 1 hour, yes, 34.28. Then after cough and sneezing, yes, 7.48. Then after cough, after touching nose and eyes, 19.22%. After caring for sick, 47.0%. Before, after, and food intake or preparation of food, 96%. Before eating, the hand washing frequencies increases 98.99%. After using the toilet, yes, 15.54%. The mean interval of frequency clean and disinfected the touched objects and surfaces the home and work environment. Yes, the frequency is 3.58 with the standard deviation is 1.28. It is a significantly correlated. The interest for self-isolation, yes, 65.22% is a self-isolation. Then social distancing, 26.92%. Moreover, after surge of COVID, first wave, the social distancing is very less. That is fairness has been decreases over the period of time. Then the healthcare system would be panic. Yes, it is a healthcare system. Nowadays, our health domain has been, Indian condition, HDI is very less. Okay, is and the problem of hospitalizations and also oxygen requirement. These are all this way. The persons will be more panic rather than the general population. It would be 89.55%. The easy available person protective equipment. Yes, so for example, the purchasing of some other electronic gadgets for recording the oxygen level, then also blood pressures, then HbA1c. Okay, all the vital parameter with in connection to the clinical parameter. Yes, the personal protective is very important. Each and every receptive population, they have purchased the this kind of equipments. The wearing of mask, yes, it is a significantly associated. It is a government interventions, the policy interventions. Everybody should wear the mask and also social distancing. That is wearing mask is nearly very good in Indian context. It is 83.65% has been practiced, been observed in that particular populations. Then the personal stress level before and after a pandemic crisis. The stress before pandemic, that is the mean score is 2.86. Okay, it is it is negatively associated with the mean score. Before stress pandemic, the stress level has been declined. After pandemic, the stress as a result of pandemic, it increases 8.13. That is a marginal effect. It is a tenfold increases the stress level. Then the concern about personally well-being of exposed to the COVID population is 9.88, the mean score. Then the concern about the family member exposed to COVID, 8.69. It is obviously it is a relative comparison is very excellent when compared to the family members exposed to the COVID. It is a the stress is a very important precursive parameter to decrease the anxiety level. Then the summary, the results clearly envisage that the respondent at medium age group shows a high level of stress, anxiety, inclusion with the general populations as well as the healthcare workers. This finding shows that major psychological impact on the quality life and general well-being of younger age populations. The younger age with respect to the 40 to 45 or less than 30 years age populations. It exists among mixed population of public and frontline healthcare workers. Already we have included that two populations. In the context of COVID-19 lockdown, which is consistent with the moderate augmentation seen in frontline healthcare workers. Besides with the mild symptoms of anxiety, stress in early stage of the pandemic, okay, that is a before when the healthcare workers has been actively involved for the patient management, automatically the anxiety or stress level also increases in the frontline healthcare workers. However, fear is a well calibrated to actual threat. Many people suffering from COVID outbreak threat, it can be manifold risk factors. So many manifold risk factors we have been observed to decline the overall well-being of quality life of persons. That is a QOL level decreases over the manifold risk factors. The social media, watching TV, news will be deliberately affect the negative psychological feelings of the persons, inclusions with the anxiety. The conditions in which frontline healthcare workers and general public to cope with the pandemic are extremely affecting the life in many ways. The rapid spread of the disease, the large number of people affected in that particular population, especially the second wave mounting with the number of deaths, the health system, that is a mistake of health system, ignorance and disinformation about the healthcare professions have contributed significantly to the fact that both the population experienced the fear and anxiety of the COVID-19. This fear has been recursive factors that influences the person's depressions, and the effect of this fear on increased trend of depressions could be worsened, especially the anxiety with healthcare profession experience the higher chance of exposure to risk and face extreme workloads. Okay, here that is all healthcare workers during the pandemic crisis, extreme workload to increases the stress and also anxiety. Then rapidly varying with the work environment with the climax of extraordinary stress among healthcare providers during the rapid outbreak. The high infection risk also stigmatization with respect to the COVID anxiety. The significant relation was seen in the general hygiene, the sleeping and preventive measures, economic status, educations, and the preventive behavior of the washing, wearing mask and protective gloves reduce the infections. On the other hand, the present study noticed that the level of anxiety more in both healthcare professions and general population due to social stigmatizations and phobia. The large-scale infectious diseases or outbreak of high severity were still uncommon in the most of the countries. The solution of this problem will be by dissemination of health information in an appropriate and accurate manner among the media and virtual platform. Here, even every platform, that is a virtual platform, even a gadget, usage of gadgets, okay, then even TV media, they will provide very good information, healthy information to the public. Then only the stress and anxiety level has been decreases. When you feel anxieties, yes, go outside. Okay, that is the preventive measures for decrease the anxiety or the prevention measures for control of the anxiety. When you are feel anxiety, go outside, take breathe, deep breathe, ask for help for somebody's, then creative something. Okay, say for example, you are actively involved in the painting and other that is agriculture work, and also some gardening work, and also that you have to think about creative something. The drink water, plenty of liquid you have to take. Then write about how you feel about that is a previous historical events. Then take a deep breath. Okay, exercise. Okay, then yoga and yoga therapy is a one kind of decrease the anxiety and also the fear. Then listen to the soothing or songs. Okay, the music decrease the anxiety. They stay present. You have to always think optimistic way. Yes, I will give some contribution to the nations. I will work hardistic phenomena. This kind of the stay with positive mood will decreases the anxiety. Find a positive distractions. Yes, the positive distractions. You play with your own children. You play with your geriatric populations or old age populations, and also parents. Yes, the distractions of the mood is very important with respect to the anxiety. Then for the well-being of the populations, for with respect to the public or the general populations, avoid excessive exposure to media. Okay, yes, that is a very wonderful key indicators. You should avoid excessive exposure to watching TV and other platform. Then connect through the calls or text or internet. Yes, you have to always so many population, the younger population has connected with chatting with some information to the public, and also LinkedIn and other Facebook. You have to avoid. Add extra time for daily stress relief. Okay, you have to make a timetable, a scheduled time. You make a free, then you have to go to outside, then you have to take a exercise, physical exercise, and also some actively involve some other work. Then practice self-care. Yes, self-care is very important. Then focus on your mental health. The mental health is very important. Okay, it is you have to always think positive mode, and also the positive attention is very important for the populations. Then risk for kid, reassure that they have, you have to actively you should involve with your children's actively, painting some other work. Let them talk about their worries. Okay, then share your own coping skills, limit their news and exposure, create a routine and structures. Okay, these are all these the another preventive strategy for COVID anxiety. For quarantine and isolation population, keep in contact with your loved ones. Okay, yes, anyhow the persons who are under quarantine or isolation period, yes, keep in contact with other with your family members or loved ones or your friends on social media, text or phone calls. Then create a daily self-care. Okay, then keep yourself busy with respect to the games, book reads, and also movies, watching movies, and also some other positive indicator movement, actively involved with some other busy with your work. The focus on new relaxation techniques. Yes, you have to focus on new relaxation techniques. Say, for example, yoga, and also some other chanting with respect to God, some other listening of musics. These are all this way you have to reduce the anxiety. Then the conclusions, the present study concludes that there is high level of anxiety, fear, and stigma among health professions and general populations. Considering stress, mental health by spiritual manner, we have to reduce the COVID anxiety and fear by spiritual manner. The family support, each and every family should support your well-beings of the family members, and also psychological counseling is very essential part and play a significant role in strengthening the immunity. Okay, this is the very important. In addition to that, certain practical measures like inception of post-exposure prophylaxis (PEP), then family health insurance, and also receiving of the vaccination, then COVID-induced death need to be taken to the decreases the fear and anxiety level in selected populations. The resource poor countries, especially some other resource poor countries, should address the key issues and control measures at early stage of infections and heavily acquainted health preparedness during the interventions of COVID-19. Okay, these are the widest conclusions with respect to the study interventions. Then acknowledgement. Yes, finally I would like to acknowledge my competent authority with respect to ICMR, Government of India, for their moral support and encouragement. And also our sincere thanks to and appreciations also extended to the people who are directly or indirectly helped us for compilations of entire research work. And also I'm going to extend my sincere thanks to Dr. B. Narasimhamurthy, that is National Health Mission expert to intervene this study for giving wonderful inputs for completion of the study. And also we would like to acknowledge organizing committee of the conference and chairpersons and also senior professors of the today's seminar or conference. Thank you so much.
Thank you, Dr. Basavarajaya, for your valuable presentation. Our next speaker is Professor Mervat Elhoz, the CEO of Environmental Engineering Consulting from Lebanon. And I request Professor Mervat to start her presentation.
I'm going to talk about sustainable waste management through circular economy, technology, policy, and participation. Ongoing problem.
Yes, please continue.
Okay. Ongoing problem because of the increase in waste generation and the lack of effective and sustainable waste management strategies in many countries, and specifically the countries in developing. Municipal solid waste is a secondary material that closely relates to our daily lives of basic living situation. Who are in charge of this sector? Scientists, engineers, society, economic sectors, politicians, politics, and other professionals are involved in undertaking the problem. So everybody is included in the strategy. So transformation into a circular economy focused on closing the loop. So before we had linear method, now we are closing the loop for circular economy, where we have recovery of material, and at the same time, new businesses can be established, and we can save the environment and reduce public health. So the objective of my study is to provide an overview of the development of waste management to date and analyze them from different points of view, from the governmental, financial, infrastructure, urban, social, health, stakeholders, and technical. Why? To provide strong recommendations to guide decision makers relevant on the way how toward the circular economy for the waste management. I want to move the, okay. So global municipal solid waste management, as we say, population is increasing, so generation rate of municipal solid waste is increasing, and it will reach 1.42 kilogram per capita per day by the year 2024. So since population is increasing, that means the consumption of materials is increasing. Consumption of materials, that means we have packaging, plastic, paper, bottle cans, all of these will be increased. So when they will be increased, so the total municipal solid waste increase by 2 to 3%. This increase will have effect on environment, and we have to have facilities, infrastructure to do that. So how to solve the problems? If we don't have infrastructure in our countries, we cannot solve it. Example, Lebanon has organic material, for example, 52.5%. Meanwhile, high income countries, they have 28%. Low income, 64%. What does it mean, this one? That means we rely too much on the food in our waste. We cook at homes, and we don't have fast food to have reduced solid waste at home. Meanwhile, for the paper and cardboard, because delivery is too much high, so high income countries, so the paper and the cardboard is 30%. So it means it's very, very high compared to low income countries who are cooking and eating at homes. So approximately 60% of waste is disposed in landfill. Till now, it is disposed in landfill in big cities, and it's in open dump in rural areas, so which is a problem. Sometimes the cities do not have available land, so the problem is created. Waste incineration is very limited in many countries, predominated by cost, because the incineration is costly, so it is not affordable in developing countries. Also, composting, centralized composting, has not been successful in some countries. The reason why, because we will see later, the collection and transport is not feasible, so this will affect on the production of waste and how clean is the waste to be treated and to be recycled. Collection and transport. Waste collection and transport are the most public visible aspect of municipal solid waste. So you have this one, highly sophisticated trucks, you have normal, and you have the poor one, you know, so it depends, and everything is costly. When you have money, that means you have a better system. When you don't have money, you have bad system. Collection service should be reliable, efficient, with the use of a truck and a proper route development. Why proper route development? Because there is a difference between coastal city and inland city, narrow streets and wide streets, narrow villages and big villages. So all of these will affect on what type of collection and transportation shall we use. So in addition, schedule should be developed and implemented for collection. We cannot every day collect all kind of waste because it is costly, and this will cost the government and will cost the municipalities high amounts. So municipalities in developing countries are paying approximately 70% of their budget on solid waste, and even though it is not well managed. So since they are publicly visible, so that means the choice of container and vehicles is influenced by many factors, such as nature of waste. So bio-waste is different. The container for bio-waste is different than the container for recyclable materials. The size also is different. Topography of the land, road network, narrow or we have good road network or not, frequency of collection, population and distance of treatment, disposal site. So we have different containers. As you can see, for example, here we have this kind of containers. They are properly neat, but if we have the barrel or oil barrel, so that means the recycling of such containers, of such waste in such containers will not be good, will not be very good. Container capacity varies from 250 liters, 60 liters, 1,100 liters, and upward it depends the area and what kind of waste do you have. A truck's capacity also 5 cubic meter capacity or 10 cubic meter or larger. So before going into a treatment of solid waste, we have collection and transport. Collection and transport, they are costly. If we don't pay very good amount of money and we select the very good transportation and containers for the waste, for the solid waste, we reach nowhere. So that means we cannot reach circular economy and we cannot reach sustainable or integrated solid waste management. Municipal solid waste technology. So it depends. If we have one truck for everything, mixed municipal solid waste, if we are collecting everything in one truck, so that means it goes to landfill or it goes to sorting plant. From sorting plant, it goes to thermal treatment, waste to energy, and to recyclable materials. If we do sorting and biological treatment, for example, anaerobic digestion or composting. So sorting, the biological treatment, then sorting for the second time, it goes to RDF, refuse derived fuel, recyclable material. But these, if we don't have market for these recyclable materials, they will end up in the market will fail and they will end up in landfill. So the treatment here and the sorting is very important to succeed in treating municipal solid waste. If we have separation of municipal solid waste at the source, organic material aside and inorganic material on the other side, so organic material straight away go to biological treatment. From biological treatment, we will have output, compost or soil conditioning, and you can sell it into the market. And the dry material goes to recyclable materials, plastic paper and the cans, cardboard, all of these will be recycled and will be treated professionally. So municipal solid waste treatment and their products. So we have biological conversion, we have landfilling, and we have thermal conversion. If we are planning to have thermal conversion, so we have to take into consideration the energy recovery technologies and the thermal treatment of residual waste in cement kilns. Landfilling, collection of gas from landfilling also give you thermal conversion. Anaerobic digestion, we said biological treatment has two kinds. One is aerobic composting and the second one is anaerobic digestion. In the anaerobic digestion, electricity or energy is produced. So that means if I'm planning or the government is planning to have thermal conversion, so the choices are thermal through incineration, gasification, pyrolysis, or through anaerobic digestions, or through landfilling, where only energy or electricity is produced. We are talking about circular economy, so linear economy, which is design. So we design a process, raw material. So design, so raw material, we produce paper, we produce plastic, we produce all of these material, recyclable materials, we manufacture them, we consume them. After consuming them, end of life is incineration or landfilling. So this is linear processes. What we are talking about is circular resource. Circular resource, that means at the beginning, we have to reduce our waste. So by instead here, after consumption, we consume them after, instead of going to end of life services. So we do source separation, which give us a clean products, collect them properly, sorting them properly. We do recycling, we do processing for recycling, we do marketing, and this is the loop. By this circular economy for waste management, we are reducing the amount of waste to 2/3, which is excellent. So instead of, for example, if we have 1 ton of solid waste to be landfill, now 2/3 is put it aside. That means we are landfilling, or we are treating only 30% approximately. Separation, then recycling. Separation. Without separation, we reach nowhere. As you can see, probably because the materials can fail to market them. For example, if the bio waste, food or organic waste, are mixed with oil, of course, the composting will not be good. So and even the soil amendment will be not good. So that means we pay for the treatment, we pay for everything, and then the end of the pipe will be landfill. So recycling is the first area of intervention with a broader circular economy strategy. It presents numerous economic, environmental, and social opportunities. Of course, social opportunities, because when we have industries, when we create the infrastructure for recycling, so we are producing lots of jobs for the people, and these jobs will increase the environmental health and have better social life. Requires the creation of the right market incentives to ensure that there is a demand from the market that matches supply. For example, we do sorting. Okay, we do separation for the plastic, but in the country we don't have industry to recycle the plastic. So what will end up in? So I have a huge amount of plastic, but I don't have treatment for them, so I'll end them up into the landfill, which is wrong. So when I'm saying separation and recycling, so the government should create or should establish the background infrastructure for all the recyclable materials that are produced from the solid waste. Recycled material needs to be safe for both environment and human to be handled and then processed and reused. For example, I cannot recycle composting where it has medicine or hazardous materials into them. So that's why insisted on sorting, separation should be taken into consideration very, very well, and the community should enforce to do that. Increase in recycling would mean we would reduce our use of minerals. Of course, have less mining to disturb the environment, use less energy, and have less waste to dispose of in landfills. And we will see how in this example. We are talking about plastic recycling. For example, I have 1 ton of waste of a plastic. If I want to throw it in the landfill, it needs big area of landfill, and it cannot be treated. So when I do recycling process, this 1 ton of waste will recycle 900 kilogram of recyclable plastic. That means only 100 kilogram is waste, residual. So I save 900 kilogram of recyclable materials. And at the same time, If I want to produce plastic from the raw material, it needs 1,400 kilograms of crude oil as raw materials. So when I do recycling, so this 1,400 kilograms is gone. So I'm not wasting the money and the nature for something is not available anymore. Another example is paper recycling. Also, 1,000 kilograms of paper waste. I do the process recycling. It gave me between 850 and 950 kilograms of recyclable papers. It saved 2 to 2.2 cubic meter of wood. That means no need to cut the trees oftenly to do that. And also no need to have landfill, big area of landfill to treat them in landfill. So recycle. So we are recycling bottles, we are recycling papers, cartons, also different kinds of bottles, metals, also bottles, because the plastic has 7 kind of characteristic. We have high density polyethylene, low density polyethylene, PVC, and etc. So we are reducing all of these materials and chemicals. So recycling of aluminium, 1,000 kilograms of waste aluminium. If I do recycling, 750 kilograms of recyclable aluminium will be put in the market. That means no, for its production, 15.6 megawatt hour of electricity is gone, and 22,500 megajoule of thermal energy per ton of aluminium is gone. So, which is excellent. That means only 6% energy is needed compared to virgin production of aluminium. So, more than 60% of household waste, food, kitchen, and garden waste, as we can see in developing countries. So now we know that we have collection and transportation. The second, we have to go to treatment. What kind of a treatment shall we follow? We want biological treatment. Biological, we are not interested, let's say, in waste to energy. In the biological treatment, we have aerobic composting. In aerobic, we have open windrow, static pile, in-vessel composting, bio-drying. These are all give into the market soil conditioner or compost or soil amendments. We have the anaerobic digestion. The anaerobic digestion, also we have different kind of system. We have the wet and a dry system, and we have the mechanical biological treatment, which is also in the treatment, one of the technology in the treatment. Let's think main or existing system of integrated solid waste. We have 3 kinds of waste. So if each of these kind of waste is collected separately, bio-waste, straight away bio-waste, that's mean go to composting, go to compost, that's mean I can have good compost. Mixed waste, when I have mixed waste collection in one truck, all of the waste is collected in one truck, so the mixed waste goes straight away to landfill, and from the landfill, we have landfill gas. Okay, recyclable materials goes to sorting of recyclable materials. So from sorting of recyclable materials, some residual waste goes outside of the sorting plant, which has to be treated by landfill. Then output of the sorting material, secondary raw material, plastic, and whatever you want. So this system describes the current state of the local waste management system. So all of these figures, this one and the systems after this one, show analyzed scenarios and their internal waste stream with dark. We have the dark line and we have the dotted line. So the dark line as well as produced energy and material. From the dark, energy and material. From the dotted, give me the materials. Waste to energy system based on waste disposal on the regulated landfill. energy recovery is present only in the form of landfill gas. In this system, only waste to energy is produced from the landfill gas. Second one, mass burn. So in the mass burn, what do we have in the mass burn? Local municipal waste plant, we have mixed waste. Mixed waste is straight away. Of course, the bio waste going to composting. This is by default. Composting is essential. It has lots of positive characteristic for the soil, for the pH, for the plants, for everything. So mixed waste. Mixed waste here goes straight away to waste to energy plants. In waste to energy plants, that means I have combined heat and power. So produce of waste to energy, I will have electricity and I will have power. Recyclable materials, of course, recyclable materials, I have sorting of materials, but here I have to say something. Waste to energy, the metal cannot be burned or cannot be treated by thermal, so the metals will go back to sorting and then it will go into secondary raw materials. So by this way, mixed waste, I will extract the metals out of waste to energy treatment. So in this one, bio-waste mix, what I use MBT, mechanical biological treatment. In mechanical biological treatment, so I do very well sorting. Out of the sorting, I have RDF, refuse derived fuel, and this RDF, they can be treated in cement cleans. Or MBT, after the very good sorting of it, residue go to landfill, and residual waste from MBT go to sorting, and from sorting into secondary raw material. Here I have biostabilization and landfilling, so I can get some organic materials which can be used in on land. Bio-waste, what we said before, we have composting and we have anaerobic digestion. So bio-waste, I replace the composting with anaerobic digestion and I produce biogas. Mixed waste, I have the MBT, it gave me the bio-waste treated in anaerobic digestion, and it gave me biogas. So in this one, I have anaerobic digestion. Hello? Hello, can you hear me?
Yes, I can hear you.
Okay. So I don't know what happened. So by having anaerobic digestion, biogas production is marked with green arrow shape, and because of biogas is not a final energy. So it is not the final, it needs a treatment. So in anaerobic digestion, I have another treatment for the biogas, and it will be treated with waste to energy. So in this way, so biogas need additional treatment. So as you can see, municipal collection system should be changed with proper designated garbage collection. If I have good system for collection and transportation, I can have good output of solid waste recycling and solid waste treatment. Separation of recyclable and or compostable waste is a key. So I have to put in the plan, in the strategy, that separation of recyclable material, dry in one container, the dry waste in one container, and wet waste in another container. Plan should be set for waste to be separated and collected. For example, in Europe, Dr. Ranganathan, Professor Ranganathan is living in France, and we all know in Europe they have 5 different containers at home, one for plastic, one for metals, one for papers, you know. But in our countries, in developing countries, because we don't have awareness campaign to our people, and because our awareness campaign are costly, you know, and should be taken into consideration in any strategy. So now we are taking, we are jumping, we are hiding the stairs step by step. So we cannot go straight away into integrated solid waste management, complete, sustainable and integrated. So step by step, we have to move from zero into, we have to do plan for short-term strategy, medium-term strategy, and long-term strategy to reach what the EU is reaching now. So, and also we have to take into consideration the technologies that we want to use. For example, if I am a poor country and I don't have finance, and I want to use waste to energy treatment, and this treatment doesn't treat all kind of waste, okay, that's mean the operation of this of this technology is high. So I have to use the treatment, to implement the treatment that is affordable, operational by the local people, not copy and paste from overseas. It doesn't work like that. Otherwise, I'll face lots of problems. In other way, collaboration throughout all sectors. So that's why when we are talking about collaboration and when we are talking about participation or stakeholders, return to the first slide, scientists, government, stakeholders, private sector, public sectors, all stakeholders who are fitting in this strategy should be included to take the right decision. Ensuring effective sustainable waste management practice across the country requires an integrated national waste management strategy. Unfortunately, many developing countries, they made many strategies, and none of these strategies reached to the points that the government planned for. Why? Because probably they didn't identify the right stakeholders and the needs of the country and the priorities. So we have to set the priorities, what we want first. We want everything solved from the beginning, bio-waste, recyclable materials, waste to energy, all of that, or we will start by one simple treatment, and then we will move to more expensive, and then we will move to highly sophisticated one. So here, something very important, I used to be member of the Municipal Council of Tripoli. And in-depth meeting with the stakeholders, you know, many times the politicians interfere. Why they interfere? Because if every 4 years they will be elected by the community, so they want to show the community that they've done something good to be elected next time. But what they do, unfortunately, they use the platform of the municipality to make a market for a specific treatment or, you know, corruption. As simple as it is, corruption to get benefit of the output of the solid waste. Solid waste is money. Doesn't need professional people. Okay, engineer, economist, you know, few people, and the others are all workers. So it doesn't need highly qualified people, only if I will use high tech, you know. So at that time, I need the specific people to run or operate these high tech technologies. Indicate the necessary key policy and regulatory tools. So, okay, I want to implement circular economy. I want to implement sustainable solid waste management, integrated solid waste management. You know, I want to, why Europe is advanced in solving the solid waste and not in my country. You know, this questions always occur, but we have to take into considerations that they upgrade their legislations. Participation is from the little boy going to school into the old man retired at home. So set out an agreed approach to follow for each major waste stream. Okay, we want to treat plastic waste. Okay, let's set an industry for plastic waste. Let's say, for example, Tripoli will have an industry for plastic. Meanwhile, India, suppose India is another city, or I don't know, Calcutta is another city of is a city in India. So Calcutta will be in charge of paper and cardboard. So the industry of paper and cardboard will be in Calcutta. The industry of composting will be in I don't know, another city of India. Okay, so in this way we are distributing the responsibility among people, and that's everyone responsible for his waste. Establish priorities, a plan for its implementation and monitoring. I have to monitor. I cannot pay a huge amount of money for any treatment and I don't know how to monitor it. I don't know if the output is feasible or not. So monitoring is important. Laboratories for quality of a product is also very important. So I have to do monitoring. So investigations to the available municipal solid waste treatment in the country to visualize their conditions. I want from zero, I want to start to do treatment for my solid waste. First of all, I have to do investigation of the available municipal solid waste. What do we have? It is not copy and paste what the WHO said, Lebanon or Middle East countries, the solid waste production rate is 0.5. No, it's not true. It's not true at all, because the variation in the same country is different between rural and urban areas. So I have to do investigations on the solid waste in the country, and I have to study the national solid waste reduction program. Do we have a program for reduction or not? Not, so we have to work on it. Local communities practice sorting at the source. Do our people make sorting at the source? For example, in Lebanon, not everyone. So how can I can succeed in having very good composting output if I don't have separation at the source? Of course, I won't get it. I won't get it because probably it is mixed with batteries. Probably it's mixed with oil. Probably it is mixed with medicine. We don't know. So enforcement to the community should be made to make source separations to be able to succeed in the treatment of my solid waste. And so population growth should be taken into consideration. My plan will be short plan, medium plan, or for long plan. I have to study with short plan, then upgrade and monitor step by step to reach to the level I want, but within a specific period of time. Scarce availability of land for treatment. Yes, many coastal cities do not have availability of land for its solid waste. So unfortunately, I'll tell you something in my country. I feel shy to say it, but this is why what the politicians with the corrupted scientists took that decision. They put dump on the coast. Can you imagine? Dump. I fight at this dump many times, and nobody listened to me because I don't belong to any of these politicians, And now they are. It is the dilemma. We have the problem, We have the port. International port, and besides it we have the economic land, and besides the economic land we have a dump. Because why it is dump? Because there is no sanitary landfill in the sea. So I explained to them this is a dump and not a sanitary landfill. Nobody listened to me, and now they are facing horrible and lots of problems because of this dump. So the toxic leachate is into the sea, and no treatment, and they don't know how to treat it even. So that's why I'm saying technology should be taken into consideration based on what is available and based on what are the main sectors available in the country or in the city. I do have money, okay, I do this plan. I don't have money, probably I ask private sector, public-private participation, PPP, to do this project. And at the same time, I do lots of awareness campaign on TV, through NGOs, through schools, universities, to enforce all kinds of people to separate and to reduce and avoid their waste at the source. I do probably for the people who are living in Europe, for example, if you want to go to the market, so you have to bring your bag with you. If you don't bring your bag with you, you will have to pay for the bag, which is enforcement. Yes, so that's why if you want to go to market, you can find every family, they go to the car, bring the bags, the used bags, and put it on the, when they buy the stuff, they reuse them. So this is the awareness, kind of awareness that should be done and should be implemented in all the countries. Treatments take relative high proportion of the budget. Of course, as you see, if I want to do waste to energy, if I want to produce electricity and power out of the waste, if I want to reuse the plastic, the paper, the cans and everything, so I have to create or to establish the industries. If I don't have this industry, I have to establish them to succeed. Politicians interfere. I don't know to what limit we should let them interfere. Only if they are interfering for the sake of their people and the sake of their country. Non-integrated plan for solid waste disposal have increased the problem of solid waste management. Yes, because when there is no integrated solid waste, lots of problems are produced. So legal framework. Each country has legal framework for solid waste management. So laws in each country. Under the law X, municipalities are responsible for solid waste management and services. So that means municipalities should do the preventing and managing and cleaning of solid waste. So let's give the responsibilities on this issue to the municipalities, not interfere with the municipalities. There is government, there is Ministry of Environment, there is Ministry of City Planning, there is Ministry of Interior, okay? Each of these ministries are in charge of its work. Please do not interfere with the work of the municipalities and let the municipalities take their own decision because they know what they feel, what are the problems that they are facing. There have been a series of national waste plans. Yeah, in any countries, many plans since 1950 probably, or since 1980s. But to reach 2020 and still many countries have a problem with solid waste management, that means none of their national plans succeeded. Why? Because they didn't look at the gaps and they didn't recover these gaps. They didn't work on them to reduce them. Of the gaps that facing or the barriers that are facing municipalities in Lebanon and developing countries, significant increase in solid waste generation. This is normal. Since you have birth, you have waste production. So birth increase, waste production increase. Lack of adequate manpower and funds. Okay, I have a lack of manpower and funds, so I shouldn't go into sophisticated treatment only if I have collaborations with PPT. Inadequate waste collection system services. When I have inadequate waste collection, if I use the oil barrel in collecting my waste, what would you expect from the municipality? Do you expect that the municipality will have a good quality of waste? Of course not. Of course not. Lack of land availability, as I mentioned, coastal cities, they don't have availability of land. So they have problems in land. So we have to find some high-tech solutions for these cities. And the problem here, NIMBY, not in my backyard, not many cities accept to collaborate with other cities to collect and to treat the waste. Here, the government should play a very important role to enforce the municipalities to take the right decision. For example, I'll give you an example of my city, Tripoli. In Tripoli, we don't have land, okay? But I can say I will collaborate with the neighbor city. I do a treatment on my land, and you will do landfill, or you will do waste to energy, or you will do another treatment on your land. In this way, so when we have collaboration, that means we will have win-win situation. Not because I don't have land in my city, so my city should be full of waste. Lack of awareness and public educations. Public educations and awareness should be done and should be paid, you know, should give a very, very important role to NGOs and to universities to work on public awareness to help the municipalities doing its job. Lack of sufficient regulatory and legislations. Yes, because when you do a treatment that it fails, the regulation, you won't continue with the regulations, because why should you put regulations for something non-existing? So that's why the right decision, the right enforcement, and the right legislation. When I do that, later on, I upgrade the system. When I upgrade the system, I do amendment to the legislations, amendment to the regulations, and in this way, I can reach the objective that I am planning to. Financial unfeasible project, okay, of course. Plasma. They are talking nowadays about plasma. Oh, very good. Plasma. It is an important treatment, blah, blah, blah. But the plasma doesn't solve, doesn't treat all kind of solid waste. The plasma is very expensive. Heating of plasma is about 12,000 degrees. Municipal solid waste, if I want to incinerate it, maximum at 70 to 90 degrees, water will evaporate. So why should I use plasma? Okay, so this is of the problems that facing in many countries. Lack of management proficiencies and practical knowledge. Unfortunately, not everyone is cultured and has knowledge about solid waste. Always in everywhere they are degrading the solid waste management. I don't know why. This is psychologically solid waste, you know, as if it is something unrespectful. Meanwhile, in Australia, for example, the rubbish man is well respected, and when he go to his superannuation, he leave his superannuation at the 55 years and not at the 65 years. So they took into consideration that his life was, you know, not insecure all the time. So waste management, let's give in Europe, of course, they have the legislation, and I give example of Germany. Germany, waste avoidance is the first, has become a central policy target. When they put waste avoidance first, they reach the best quality of output, the best quality of recycling, the best quality of waste to energy. So they decide, put the regulations, apply the regulations, put the enforcement, go. High readiness in the society for separating and collecting of waste. But at the same time, they did public awareness, and they explained to their community, to their people, that separation has advantage, this and that, blah, 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 to encourage people to separate their waste. High quota on recycling, yes. Germany is one of the highest countries in Europe in recycling. Multi-way packaging is promoted. Packaging before, if you want to buy, let's say, television, you had lots of packaging materials for the equipment. Now they reduce the packaging to the half, so to reduce the waste. Strong legal emission limits for waste incinerations. Germany is an industrialized country, so they produce cars, they produce planes, they produce, it is an industrial country. So they have experience in incineration, they have experiences in plasma, in pyrolysis, and in all of these treatments. So that's why, so because they know what are the emissions produced from the industrial waste, they put some regulations on the emissions for the solid waste, the municipal solid waste. No more untreated waste in landfill site. So it is forbidden since June 2005. There is no more sanitary landfill. And what they do enhanced mining or land reclamations. All the old sanitary landfills that were established in the old days, now they are making waste to energy, so they are open it, take the waste, recycle the waste, and produce the energy out of the waste, and make the land safe. Experience also from Europe, from developed countries, strong planning, local involvement and implementation. The people of Tripoli, the people of Calcutta, the people of Bangalore, all these people, they know their problems and they have to solve their problems. Clear responsibility and cooperation between government levels. Okay, we are in need to collaborate with the ministries, yes, for sure. Because if we need legislations, if we need some regulations, if we need some standards, we have to go up to these ministries or to these public sectors to enact what we want. Juridical and financial instruments. Financial is very, very important. Really, financial is very important. If I am poor and I don't have money, and I am a country that I always take loans from outside, I should work in the solid waste according to what I have. I shouldn't go to highly sophisticated treatment. I'll start with simple one and grow up with time after modifications and upgrading year by year. Transparency and clear communication to public. I have to be transparent with my public. At the end of each month, we will say this amount of plastic is produced, this amount of bio waste is produced. We have reduction in bio waste. This month we have increase in plastic. So why? To let the people know what to do, and to if I have increase in solid waste production, I will warn the people to reduce their waste. So the main aspects and the main pillar for sustainable and integrated solid waste management: political, financial, institutional, economic, social, and technical. It is not only technical issue. Technical is part of it. I can bring the high tech to Lebanon, but I don't have the money for the high tech. And my country is under loans and loans, lots of money to World Bank and to other banks, so I cannot. So be realistic about feasible and a practical choice of solid waste treatment technology, and about committing significant investments. So don't commit to high tech and very, very expensive tech now if you don't have the money, if you don't have separation at the source, if you don't have public awareness, if. So I have to work on all of these together to take a decision and start with. So the main aspect, so revision, source reduction, selective of collection, recycling, composting, anaerobic digestion, energy regeneration from waste. These are a package. I have to work with it completely. It's one package. I cannot take recycling aside and collection aside. No, all of them are interrelated. When I have them interrelated, I can use the right bins, the right tracks, the right locations, the right treatment, the right awareness, and succeed in the treatment. So strong policy, regulation, legislation, and enforcement, the first one of the table, national policy framework with regulation, standards, and technical guidelines. I don't have standards for the quality of my solid waste or the quality of compost. I look which countries has similar compost or similar characteristic of waste. I will borrow their standards for a while, and then I made mine with time. Policy that move away from the old-fashioned disposal, that's a linear economy or linear approach, to more intelligent, which is circular technologies. But be sure that when I want to move to circular economy, I have to have the infrastructure available in my country. Waste regulations address the reduction at the source. This is a must in the strategy. Impact of waste on the environment. I have to aware my community that look, if we have high waste production, we will have high emission, siting, soil, water. All of these environmental are affected by the pollution from waste. So while some of these regulations, they are still not properly enforced in practice. In many countries, they do not practice all of these enforcement. Strong regulations, tackle the reduction. So some of them already still not properly applied on the ground. So it is written in the document, but not applied because they don't know how to apply it. So copy and paste without implementation. So social and institutional, so integrated communication program to simplify the concept of the integrated solid waste management and clarify the role of each citizen. Give charge to the little baby, to little boy, and give the responsibility to old man and to everyone. Let them be responsible on their waste. Media and advertising campaign should be all the time, continuous to not forget. So for example, look, we have dry waste, go to recycling. Wet waste, produce fertilizer, compost, you know. Reduce, reuse, recycle. I recycle all of these. That means 2/3 of the municipal solid waste has been reduced. Awareness training and population psychological reconstruction. I have to work on the psychological effect on people. Very, very important. And on the youth and on the children more than the old people, because old people, they won't listen to as much as the youth and as much as the young people. Government need to make sure to emphasize the clear communications and understand the need to separate waste. Municipal, hazardous, recyclable, or financial. So I took financial status also, since if I don't have the money, I have to introduce public-private participation to to work properly in solving this problem. So this towards circular economy. So we have green waste, we have recyclable materials, and we have non-recyclable materials. So any of these ending with landfill, but when I have treatment, so the size of landfill is less. Now they are after zero waste. The developed countries are not landfilling, as I mentioned, Europe and Germany 2005. They prohibit the landfilling, no more landfilling. So I cannot implement this one as it is in any of the developing countries. I have to start from somewhere. So various challenges such as higher cost, limited process understanding, low to moderate community and technology, all of these should be taken into consideration. So yeah, there is still challenges today. So closing the loop, sustainable municipal solid waste management policies should be adapted in our country over the coming years and should be based on circular economy. Involvement and commitment is required from all, not only from the government, municipal unions, municipality, all householders and commercial who contribute to such generation of waste. Nobody does not produce waste. All of us are producing waste and all of us are in charge of its solution. Thank you.
Sir. Good afternoon. Good afternoon, respected sir, respected madam. I am Mahesh Ashok Kumar, working under the guidance of Professor J.C. Umawati, Gulbarga University, India. First of all, I would like to thank the organizer for giving me an opportunity to participate in the conference. My title is Micropolar Fluid Flow past a two-dimensional body ampered with nanofluid, applications in polymer coating. Abstract. Non-Newtonian flow from a wedge constitutes a fundamental problem in chemical engineering system and is relevant to processing of polymers, coating system, etc. Derived by such application, the numerical solutions are computed for convective boundary layer flow of incompressible micropolar nanofluid from a two-dimensional wedge. Viscous dissipation and heat sink effects are included. Employing suitable similarity transformation, the balance law equations are reduced to first order nonlinear ordinary equation. The Runge-Kutta fourth order method is accepted to find the numerical solutions of reduced equation. Primary and secondary shear stress, wall couple stress, Nusselt number, micro-rotation velocity, and temperature were computed for the effect of nanoparticle volume fraction. Vortex viscosity parameter, Iot number, Farkman scan parameter, micro-inertial density, and heat sink parameter for different types of nanoparticles. It was observed from the study that the temperature and thermal boundary layer thickness are both suppressed with increasing wedge parameter and wall heat skin effect, which is beneficial to temperature regulation in polymer coating dynamics. Also, both primary and secondary skin friction components were reduced with increasing wedge parameter. Nusselt number was also enhanced considerably with greater wedge parameter and nanoparticles. Introduction. A nanofluid is a fluid containing nanometer-sized particles called nanoparticles. There are two types of models that are used mathematically to solve problems relating to nanofluids. One is single-phase model and the other is two-phase model. In single-phase model have been found to possess enhanced thermophysical properties such as thermal conductivity, thermal diffusivity, viscosity, and convective heat transfer coefficient compared to those of base fluids like oil or water. For two-phase systems, there are some important issues we have to face. One of the most important issues is the stability of nanofluids, and it remains a big challenge to achieve desired stability of nanofluids. Newtonian fluids obey Newton's law of viscosity. The viscosity is independent of the shear rate. Non-Newtonian fluids do not follow Newton's law, and thus the viscosity is not constant and is dependent on the shear rate. The theory of micropolar fluid has received much attention in the last several years because the traditional Newton fluids cannot precisely describe the characteristics of fluid flow for a fluid with suspended particles. Physically, micropolar fluids may be designed as the non-Newtonian fluid consisting of short rigid cylindrical elements, polymer fluids, fluid suspension, animal blood, etc. The theory of micropolar fluids was first proposed by Ehringen. The modulation of micropolar fluid model was also proposed by Ariman et al. The flow from a two-dimensional wedge is the classical problem in viscous fluid mechanics and boundary layer theory, often referred to as Faulkner's scan flow. It has been extensively studied in industrial fluid dynamics, aerodynamics, applied mathematics, and chemical engineering transport phenomena, since it provides a good framework for examining a variety of interesting flow classes, including flat plate flows, stagnation point flows, etc. The colloidal study past a wedge geometry cannot be overlooked due to extensive application in many industrial engineering zones. These comprised in thermal insulation, geothermal engineering, heat exchangers, and extraction of crude oil, etc. The flow regular liquids or nanofluids over a wedge geometry unlock a new window for researchers and scientists. Therefore, researchers and scientists focused in the direction and extended the model day by day with new advances. The physical configuration is given in figure. We have considered a steady two-dimensional, viscous, incompressible, force convective heat transfer of micropolar nanofluid from a wedge. The wedge lies in XY plane with the X coordinate oriented along the wedge from edge surface. The Z-axis is orthogonal to the XY plane. It is assumed that the external velocity is in the form of u is equal to cx to the power m, where c is a positive constant and m is the Hartree pressure gradient parameter, which corresponds to beta star for an angle omega of the edge, where T infinity and TW are the x-axis symmetrical micropolar boundary layer, where T infinity is an ambulant fluid that is free stream and TW is the temperature at wall. Mathematical formulation. The equation 1 is a continuity equation, whereas equation 2 is an x-directional linear momentum conservation, where rho nf u dou u by dou x plus v dou u by dou y is a convective term. Mu nf plus kappa dou square u by dou y square is a viscous term, plus kappa dou n by dou y is a micro-rotation term. Rho nf u du by dx is a stagnation point. The equation 3 represents the z direction linear momentum conservation, where rho nf u dou w by dou u by dou x plus v dou w by dou y is a convective part. Mu nf plus kappa dou square w by dou y square is a viscous term. The equation 4 represents the angular momentum conservation equation, where rho nf u dou n by dou x plus v dou n by dou y is a convective part. J is an micro inertia density and n is an micro inertia term. The equation 5 represents the energy conservation equation, where rho Cp nf u dou t by dou x plus v dou t by dou y is a convective part. K nf dou square t by dou y square is a thermal conductivity term. Mu nf plus kappa is a dissipation term, viscous dissipation term, and q t minus t infinity is a heat flux. The boundary conditions are at no slip condition, at y is equal to 0, u is equal to 0, v is equal to 0, and w is equal to 0, and n is equal to minus eta dou u by dou y, and qw is equal to minus k dou u by dou y. At y tends to infinity, that is at free stream function, u tends to u is equal to cx to the power m, w tends to 0, and n tends to 0, and t tends to t infinity. The transform equations used are as follows. The reduced transformation equations are: the equation 7 represents the primary momentum, where k is the thermal conductivity and f is a dimensionless stream function. The equations 8 represent the secondary momentum equation, where h is the dimensionless angular velocity, and equation 9 represent the angular momentum, and equation 10 represents the energy equation, where theta is the dimensionless temperature function, and phi is the heat sink parameter. The corresponding transparent boundary conditions are specified as at eta is equal to 0, f of 0 is equal to 0, df of 0 by d eta is equal to 0, g of 0 is equal to 0, h of 0 is equal to minus 0.5, d square f of 0 divided by d eta square, d theta of 0 divided by d eta is equal to minus 1. At eta tends to infinity, df by eta d eta tends to 1. G of infinity, h of infinity, theta of infinity tends to 0. Graphs and discussions. Profile for primary velocity for various m. From the figure, it is obtained that variation in m parameter against the primary velocity, that is, as m increases, primary velocity profile increases. Further, for large value of m, small increase in velocity is obtained, that is, profiles are very close. Profile for secondary velocity for various values of m. Figure shows that when the value of m is equal to 0.3, the significant decrease in the secondary velocity is obtained. For other values, the secondary velocity increases with increase the m, but the profiles are steady or constant. Profiles for angular velocity for various values of m. Figure shows that the effect on m on the angular velocity near the wall, angular velocity decreases as the value of m increases, but it shows dual effect in the interval 1 to 5. Angular velocity is increasing in nature, near the free stream velocity is steady. Temperature profile for various values of m. It shows that the impact of temperature increases with increase in m. Near the boundary, the temperature is significantly large. Profiles for primary velocity for various k. Figure demonstrates the effect of the vortex viscosity parameter on the primary velocity. The result shows that primary velocity decreases with increase in vortex viscosity parameter and remains constant near the free stream. Profiles for secondary velocity of for various k. Figure shows that the impact of vortex viscosity parameter on the secondary velocity. The secondary velocity decreases for k is equal to 0 and decreases in the secondary velocity very less for remaining values. The profiles are steady and decreasing. Profiles for angular velocity for various k. Figure shows that the influence of the vortex viscosity parameter on angular velocity. The vortex viscosity parameter has the dual effect on angular velocity. Near the boundary, it is in decreasing nature, while in the interval 1.5 to 5, it is in decreasing nature. Profiles for temperature for various k. In the figure, the increasing effect of vortex parameter on the temperature is observed. At the boundary, temperature is maximum value on the boundary for large value of vortex viscosity parameter, and also decreases towards the upper end. There is no temperature variation is seen. Profiles for primary velocity for various phi. Figure demonstrates that as particle volume fraction increases, primary velocity increases. At the boundary, primary velocity is diminished for all values of particle volume fraction. Profiles for secondary velocity for various phi. Figure shows that small value of particle volume fraction decreases in secondary velocity is obtained, while the significant value of phi for secondary velocity does not converge. Profiles for angular velocity for various phi. Figure demonstrates that the particle volume fraction shows the dual effect on the angular velocity. At the initial boundary layer, as phi increases, angular velocity decreases. In between the interval 1.5 to 5, angular velocity increases for increase in particle volume fraction. Profiles for temperature for various phi. It shows that particle volume fraction is increasing effect on temperature. For large value of particle volume, temperature is significantly decreased. Near the boundary, for initial value, temperature increases for smaller value of solid volume fraction, and when the higher of the phi significant decreases in temperature is observed. Profiles for temperature for various phi. Figure shows at the heat sink parameter is 0 and temperature is high near the boundary, and for the other value of heat sink parameter, temperature increases with increase in interval 1.6. For all values of heat sink parameter, the profile remain constant. Profiles for temperature for various Iot number. It shows in the figure that Iot number increases. Figure shows that the temperature increases near the boundary. Towards the boundary, profile is going on decreasing. Profile for temperature for various nanoparticles. In this figure, it illustrates that the effect of various metallic and non-metallic nanoparticles on the temperature near the boundary. Titanium oxide nanoparticle shows the higher temperature compared to all other. Silver nanoparticle shows the minimum temperature after eta is equal to 0.4. The reverse effect is observed. The table shows that the comparison of the published work by Yai, Chamka et al., Ishak et al., and Udin with my present work, it is seen that the results are in good agreement with literature work. The table shows that the comparison of published work by Lin, Ishak et al., Udin with my present work, it is seen that the results are in good agreement with literature work. Conclusion. In this analysis, a mathematical model for excess symmetrical micropolar nanofluid convection boundary layer from two-dimensional wedge with heat sink and viscous dissipation effects have been studied. The dimensionless ODVVP is solved with Ringokuta fourth order method. The effects of various parameters such as primary velocity, secondary velocity, angular velocity, and temperature are presented graphically. The following results are drawn. Primary velocity and temperature profile increases for various values of Hartree pressure gradient parameter. Primary velocity for various values of water viscosity parameter decreases while temperature increases. These are the references which have been used to solve the problem. Thank you, one and all.
Just a second, I'll set up my PPT. Yeah, okay. A warm welcome to all the dignitaries present here. This is Sham Sashwatara from PSG College of Technology, Coimbatore, India. So today I'll be focusing my review talk on hydrogen as a future energy carrier and the use of metal hydride storage systems. So moving on. So I'll be organizing this review talk into the following points, starting from why is there a very important need for alternative fuels and why hydrogen as a fuel is very important for this, and how the automotive industry, the current industry, utilizes this particular fuel for its mobility purposes and propagation. Then I'll be moving on to the global development of hydrogen and different storage systems available. And as the title of my talk already mentions, I'll be throwing a little bit of more emphasis on metal hydride storage systems in particular. Then I'll be explaining a brief explanation about the initiatives, policies, plans undertaken by the Indian government. And also I'll be giving a very brief idea of what the global scenario is all about these things. Then moving on to the ongoing projects which are currently happening in India. And of course, I need to also talk about the drawbacks which the industry is currently facing right now. Then the conclusion and references. So what is the most important need? Why are we looking for alternative fuels? That is the big question out there. So as you all might know that fossil fuels are replenishable, and it can lead to unstable energy supplies, and more drastically, it can lead to climate changes and environmental degradation. So it consists of all these drawbacks. But if you look at the scenario out there, most of the energy demand, the energy thirst is being satisfied by fossil fuels, which are non-renewable. The world nearly consumes 90 million barrels of oil a day. And just imagine the amount of fossil fuel being consumed. And what are the research community doing to put forward or to prevent this kind of consumption and to move on to an even more cleaner perspective? They are conducting research on how to improve the efficiency of fuel consumption. How does vehicles utilize the fossil fuels, or how drastically it can impact the environment? And also lately, new renewable energy source technologies are coming up, which can serve as a very good alternative to fossil fuels. So there are a lot of renewable energy sources available out there. It can be solar, wind energy, and many other cleaner sources. But out of all these energy sources, I'll be throwing a spotlight on hydrogen in particular. It seems to be a very promising contender. In the subsequent slides, I'll be explaining why do we consider hydrogen to be a very promising contender when there's so many options available out there. So the particular thing or something which all the global leaders would like to focus on is a strong need for a lasting solution. And I emphasize once again, they require for a lasting solution and not something which is going to be staying only for a couple of years or something. They want something which is eternal, a lasting solution to climate change. So if we consider hydrogen as a fuel, why is there so much importance? As I told that I'll be explaining in the further slides, let me start with the basics of why do we consider it as a potential fuel. One thing is it has a very low energy density per volume, and it also has high energy density per weight. This is something which I don't want you people to get confused. Low energy density per volume and high energy density per weight. And also it's a versatile energy carrier. The hydrogen economy or the world hydrogen cycle is something which every automotive industry or marine industry, any industry, it's not something which is accustomed to the transportation industry alone. That is something which they envision. And let's have a look at this hydrocarbon cycle. This is the current data which I could show you people. So as of now, about 75% of the world's energy is satisfied by oil, gas, coals. And what are these oil, gas, coals? They are, of course, fossil fuels. And what are they subjected to? They are subjected to combustion. And from this combustion, we derive energy, the useful energy, which can be used for various purposes. But apart from this useful energy which we are using, what are the byproducts of combustion? You get a lot of harmful gases, the carbon monoxide, nitrogen dioxides, or sulfur dioxides, and all these kind of outputs, the results of these combustion, are they of any fruitful purposes? Of course, they might be fruitful to some extent, but on the major side, on the eye-opening side, it leads to a lot of disadvantage only. Like, as for example, if you take acid rain, what are the main causes of acid rain? It's carbon dioxide, sulfur dioxide, nitrogen dioxide. And where do we get these pollutants from? It is the result of combustion. So likewise, these hydrocarbons have a lot of disadvantages. So many developing countries are suffering from a serious energy shortage due to this. They're unable to use fossil fuels to a larger extent because on the same side, they don't want it to be a major reason for climate change as well. So they're like stuck in a dilemma, whether to choose for fossil fuels or whether to look for a future or focus on our climate. So to avoid all these dilemmas and things, we look for alternative fuels. More importantly, not only alternative, that fuel has to be cleaner, efficient, and it could be a very fruitful for the longer run as well. That is where hydrogen comes into play. And this is a brief idea of the world hydrogen economy. And the future environment is something which involves hydrogen. That is what I would like to emphasize here. And there can be various renewable energies, solar radiation, hydropower, and wind energy. All these things are fluctuating. They cannot be used continuously, or they cannot be completely relied upon, which is where we can bring hydrogen into play. And the one fascinating fact which I can put forward here is that hydrogen is slowly replacing today's secondary energies as the ideal secondary energy vector. And this potentiality, the development of this potentiality can help in very good long-term results, I would like to emphasize. And if we particularly focus on the automotive industry, like I can definitely point out that around 3 to 4%, or let me say 10% to be on the safer side, 10% of the world's total global emissions is caused by the automotive industry. So what have they done to avoid these kind of emissions? Earlier, we were very accustomed to internal combustion engine vehicles, and that is what which we could primarily see when we go outside. But now there's a significant transition from ICEs to EVs and HEVs. So electric vehicles and hybrid electric vehicles are the new trend in the automotive industry, and that is what every industry is like focusing upon right now. But what is their primary goal in doing so? One is to decarbonize the industrial sectors, lower the carbon emissions, which is one of the primary factors for climate changes, and also provide longer ranges. This particular longer range aspect is like one of the most difficult aspects which the industry is facing right now. If I take a normal EV, it might not be able to give a longer range. If I want a longer range, I have to pay more. And the cost of buying, cost of procurement, or the cost of purchase would be very large in this case. So to overcome this longer range things, the industry has to now undergo a transition from EVs to an alternative source. And also, at the same time, they have to focus on EC usage and storage of any fuel. It can be electricity or hydrogen or any other chemical. They have to be focusing on EC usage and storage. And encompassing all the aspects which I have told right now, hydrogen seems to be a very better option. And also, what is the current need to bring in commercialization of hydrogen as a cleaner fuel? Only when this is commercialized, long-term aspects can be fulfilled. And I can't just talk about hydrogen when it comes to the automobile industry. Where am I going to apply this hydrogen in the industry? That is where fuel cells come into play. So in fuel cells, hydrogen is one of the key primary energy suppliers. So in EVs or HEVs, fuel cells seem to be a very better. I'm sorry. Hello.
Please continue.
Yeah. Okay. So in EVs and HEVs, we are primarily using batteries. So instead of batteries, we can look forward as fuel cells as an even better option. And inside these fuel cells, we use hydrogen. What is the benefit of using fuel cells in terms of batteries? In fuel cells, the chemicals continuously flow. They are not stationary. And one important advantage is that they produce electricity as long as fuel is supplied to the fuel cell, as opposed to batteries. And these fuel cells would definitely require highly purified hydrogen as fuel. And if you have a look at the transportation sector, we have fuel cell vehicles, fuel cell buses, fuel cell trucks, fuel cell submarines, trains, coal mining cars, and many more. And researchers are developing a wide range of technologies to produce this particular hydrogen, which is used as a fuel in these cells in a more economical aspect from a wide variety of sources, and also at the same time focusing on the environmental friendly techniques as well. And have a look at the global development or the global scenario. What are happening in different countries in the world in producing hydrogen or commercializing hydrogen? Let's take the example of Belgium. Belgium is trying to collaborate and make fuel cell and hydrogen as a part of everyday life. They're trying to make it an everyday reality so that it becomes so common that whenever you step outside your house, you're going to see a lot of hydrogen cars, hydrogen vehicles, and everything is sustained by hydrogen. And taking the case of Japan, they are making changes to the energy policy and prospects of hydrogen energy. And also there's a lot of advances and progresses in the US DOE hydrogen and fuel cell programs. And if I take the example of Germany, they are using concentrated solar radiation. And that is one of the important options for large-scale renewable hydrogen production. That is something innovative and something to be looked upon. And in Europe, you can find a lot of fuel cell buses also nowadays. And that is one important step towards commercialization pathways. And Germany is also developing cryocompressed hydrogen storage systems for automotive applications. BMW, Daimler, Porsche has been researching upon these particular storage systems in Germany. And also they are trying to come up with new hydrogen refueling station networks similar to the EV charging networks and the route optimization of trucked-in hydrogen in Germany. And as you all might know, Daimler has come up with hydrogen fuel cell trucks, which is one of the first automotive companies to manufacture the same and implement it. And in the case of France, there are multi-gas field analyzer which directly measures pollutants at HSR for ISO 146872. That's the name of the standard being used in France. And with now moving on to this hydrogen storage systems, I've spoken about the global scenario and why hydrogen can be a potential fuel. Next important aspect is the storage aspect. Like how are we going to efficiently store hydrogen? What are the available options out there? One basic thing is hydrogen can be stored either in the form of gas or liquid. That is the physical aspect. And if we take the example of gaseous hydrogen, gas storage requires a very high pressure, somewhat in the range of 350 to 700 bar tank pressure. And if we take a liquid hydrogen, liquid storage requires cryogenic temperatures. Why do we require a cryogenic temperature in this case? Because the boiling point of hydrogen is 1 atmosphere. At 1 atmosphere is approximately minus 252.8 degrees Celsius. This is the reason we have to look for cryogenic tanks or something which operates at cryogenic temperatures. And also nowadays, hydrogen can be stored on the surface of solids by the process of adsorption, or also it can be stored within solids by absorption. And currently, the available options for hydrogen storage are, one is the high pressure gas cylinders, and next is the liquid hydrogen in cryogenic tanks, or by the help of liquid chemicals, we can store hydrogen, or through porous materials. And this porous material is something which I earlier talked about, the adsorption process. So carbon is one of the most potential materials in which hydrogen can be absorbed, or carbon nanomaterials can also be utilized, glass microspheres and metal hydrides. So the reason for me to put metal hydrides at the last of the available options is that it is one of the key things which I'm going to emphasize right now. And also it is one of the key important points of my research review right here. So why do I have to emphasize about metal hydride storage systems when there are so many available options out there? One thing is metal hydride storage systems can store hydrogen at a very nominal temperature or a room temperature, and also at atmospheric pressures. It doesn't require any manipulation or additional efforts from the human end in order to store it. It can be stored very easily with the available conditions out there. And one, it can help us attain high storage capacities. And also it has an ability to absorb and release large amounts of hydrogen gas multiple times without deterioration. Now, without deterioration, in some of the storage systems, it is subjected to deterioration. When you use the hydrogen gas for multiple cycles, it loses its efficiency, and at the end, it contributes on a larger scale to deterioration as well. So all these things can be avoided by using metal hydride storage systems. And also one important aspect is that the absorption and release rates can be controlled by altering the temperature and pressure. So when you alter the temperature and pressure, which can be manually done, the absorption release rates can be easily controlled. So this manipulation becomes very easy. And then it is one major aspect is it's very environmental friendly, and it requires very low grade thermal inputs. You don't need bombastic inputs there. And it's quite compact and consists of no moving parts. So that makes our work very easy. And also, this hydride storage systems can be utilized for the automotive industry, since they are very safe storage media for mobile applications. Can be easily transported, and it is not subjected to any chemical change or a decomposition when it's subjected to a mobility. And also it can be effectively used for more than 15,000 cycles without any deterioration happening. So these are the key important advantages, I would say, when it comes to metal hydride storage systems. And also if you take the scenario in the United States of America, HYSA lab systems are conducting research on metal hydride system. I have shown the image of the cryogenic tank which they have come up with. This is the exact tank which they have designed, and the parts are labeled as follows. And I believe this presentation would be shared to all the dignitaries out here at the end. So maybe you can have a look at the different parts or how it is designed. Or you can also visit the HYSA website for further information about how they have designed this particular cryogenic tank for hydrogen storage. So moving on to the different initiatives which the Indian government has put forth to commercialize hydrogen and to try to show the need or importance of this hydrogen to the public, as well as to improve the energy scenario out here in India. The first thing is the Ministry of... Sorry? Did someone try to say something?
No, it was just a disturbance. Please continue.
Yeah, okay. So the Ministry of Non-Conventional Energy Sources has supported various demonstration projects through the Indian Oil Corporation, the Society of IAM. And the first demonstration project was for setting up a hydrogen dispensing station by the Indian Oil Corporation at their own petrol pump at Dwarka, New Delhi. This is one of the first hydrogen-based projects which the Indian government had come up with. And likewise, various other projects, the dispensing station. And also one more thing, for want of time, I'm not going to explain each and every project or initiative taken by the government. When the slide is shared with you, maybe you can have even more closer look. I'll just give a very brief idea during my talk here. So yeah, that is about the first demonstration project. And the second project was implemented by the same Society of IAM in association with the top 5 automobile manufacturers in India: Tata, Ashok Leyland, Eicher Motors, Mahindra and Bajaj Auto. So in cooperation with the Indian Oil Corporation, they demonstrated the use of hydrogen and how they can blend hydrogen with CNG in the automobiles. And also the Ministry of New and Renewable Energy had come up with very broad-based RD&D projects on different aspects of hydrogen energy technologies out there, which also focuses on production of hydrogen, its storage, and how it can be utilized for both mobile and as well as stationary applications in correlation with the internal combustion engines and fuel cell technologies. So I had earlier talked about the Indian scenario. Now I would like to emphasize on the global scenario as well. What are the different countries and unions doing out there? What are the policies they're being put forward to reduce the usage of internal combustion engines and make the public undergo a transition to EVs and HEVs. So if you take the example of the European Union, they've agreed to it for a 3% cut of truck and bus CO2 emissions by 2030. So by 2030, they are trying to reduce the carbon dioxide emissions to a very drastic level. And in the case of Norway, combustion engine vehicles sales ban is going to be put forward from 2025. So the public would be able to only purchase EVs, HEVs, and other hydrogen-based or renewable-based automobiles out there. And that is the case with many other countries like China, Korea, Germany, UK, France. They've come up with country-specific norms or policies which can help them abolish or completely bring down the usage of ICE vehicles to a negligible level. And also the primary companies, they have come up with green car strategies. If you take the top original equipment manufacturers out there, starting from Volkswagen, Hyundai, Toyota, and Volvo, they have come up with company-specific strategies which they would be putting forward for an even more greener future. If you take the example of Volkswagen, they are trying to stop making gasoline and diesel cars completely in 2026. And if you take the example of Hyundai, Hyundai plans to introduce 38 eco-friendly vehicles by 2025. And when I say eco-friendly, it's not only EVs, can be a hydrogen-based vehicle or a hybrid electric vehicle, a plug-in hybrid electric vehicle, and many more renewable aspects. And also they've come up with the fuel cell electric vehicle Vision 2023-2030 plan as well. And taking the case of Toyota, Toyota aims to eliminate gasoline cars completely as the above two companies by 2040. And Volvo is also trying to use only electric motors in its cars from 2019. So like this, many other companies and automotive industries trying to emphasize the use of renewable energies. And this is one way in which they could establish their stand in the green automotive industry. And these are some of the ongoing projects in India with respect to hydrogen usage. Just to give you a brief idea of what is happening out there and what the different colleges, universities, industries, government are being put forward. And you could have a look at all these things maybe in your leisure time or something. Yeah. And also, as of now, I've talked about various advantages or what are the pros of using hydrogen. Also, in this as a scenario, I should also talk about what are the drawbacks, what are the things which have to be overcome to make it an even more potential option. So one drawback is that electrolysis and steam reforming, the two main processes of hydrogen extraction, are very expensive. It cannot be easily set up or put forward. It requires a large amount of capital. And also hydrogen needs to be stored under very high pressure to avoid any decomposition or any unwanted chemical reactions taking place. And compared to other gases out there, hydrogen lacks smell or odor or any other thing. You can't easily detect hydrogen. So because of this, even if hydrogen leaks out of the storage capacities, you wouldn't be aware of it. So it requires specialized technology or systems to be able to detect if the hydrogen is leaking. And also there are a lot of present challenges when it comes to usage of hydrogen. And when you have to move large quantities of hydrogen, it is somehow very difficult. And you have to move it only in small batches. You have to split an entire amount of hydrogen into small capsules, and then only you have to transport it. And one important thing, even if you look at the title of my review talk, I have mentioned that hydrogen is a future energy carrier. I have not mentioned it as a source. Now, why do I not call it as hydrogen as a future energy source? There's a very significant difference here. So the reason why I'm telling that hydrogen is an energy carrier instead of an energy source is that hydrogen always exists in conjunction with other elements out there. Take it water or hydrates or any other things. It always exists in a combined state. You can't find free hydrogen so easily out in the environment. So we always have to extract hydrogen from a combined state. This is why we call it as a carrier rather than a source. So if I take oxygen, I can call oxygen as a source because free oxygen is easily available out there. But that's not the case with hydrogen. And that is the reason why we emphasize on the need to call hydrogen as an energy carrier. And also the existing infrastructure, the chemical infrastructure is not so lavish or not so lavish to be able to accommodate hydrogen as a fuel. So the significant development in the infrastructure also has to take place so that hydrogen comes at par with the electric vehicles and hybrid electric vehicles in the current automotive industry. And slowly moving on to the conclusion of my talk, as I've discussed earlier, hydrogen is a very good potential fuel which has a very high heat value, and it also has a large number of benefits. The number of benefits which it is carrying right now, it covers the amount of drawbacks. It covers the amount of drawbacks. So the amount of benefits are more. So we can always go for hydrogen as a green fuel. And with increased focus, the countries around the world, and with improved R&D, extraction of hydrogen will be very easy. And it is certain that hydrogen would be the fuel of the future. But as I told, hydrogen storage is still a very major issue of concern. And a lot of work is still expected on this sector to make it a more viable option. And if I consider the Indian economy, switching to hydrogen will surely decrease the oil imports of nation and dependency on other nations for energy source supply. And finally, I would like to thank all the dignitaries out here for listening to me patiently. And a special thanks to Mr. Nawaz and Mr. Rajabhushan for coordinating this entire webinar and putting forth this amazing event out here. Thanks a lot. And I'm open to any questions.
The viral electrical detection, and that's me, Mahmoud Ahmed from the Electrical Engineering Department at the United Arab Emirates University. This is the outline, the interest, electrical viral classification and quantification, introduction to electrical detection based on what, present advancement in detection, electrical detection, concluding remarks, and an outlook. I think as we have seen with the recent COVID-19 pandemic, viral outbreaks or pandemics can result in numerous global, social, and economic problems. In particular, this outbreak has highlighted the need for rapid diagnosis and detection mechanism that can play a major role in stop spreading virus. Although some studies show that a few hundreds to few thousands viruses are required for a person to contact and have a viral infection. Hence, the detection method that we are looking for should be scaled to detect down few virus particles and can be transferred into functional prototype and commercial product that can be used by the public without the need of a skilled person to help and carry out the test. I think having such a method is of extreme importance, and any improvement in this direction will effectively make a difference between life and death. So far, different viral detection concepts have been developed. Advancement in integration of bio-sensing mechanism and electrical characterization techniques have provided a powerful potential and a huge impact in developing point-of-care system. In principle, such biosensors are capable to transform biochemical information such as analyte or particles concentration into an corresponding electrical or voltage signal, which can be measured. Applying signal processing along with barometric modeling techniques can help us to make the right decision about the sample under test, whether there is virus or not. Why electrical? It can be label-free. We don't need biomarkers. And indeed, if someone look into the literature, you will see a huge interest in the last decade in developing label-free techniques, because the cost of the test will be very low and very cheap and in the hand of everyone. Why electrical? Because most of the existing techniques suffer from limitation and they require extensive sample preparation, time consuming and costly, like for example, the PCR. Therefore, a systematic label-free virus quantification, the viral load and identification, classification, the virus type by electrical parameters has not been yet defined or developed. Nevertheless, there are some trials here and there to come up with the techniques that can meet certain requirements. This is working well for specific type of virus, but is not a universal technique that you can apply it for all type of viruses. We know all the conventional way how to do virus quantification was based on antigen detection, such as the GAP gene and genome detection of virus specific. And there's an issue with the dynamic range of detection and limit of detection. This is why most of these techniques require high concentration, which are difficult. Okay, what we are looking, as I said in the interest, that we need a technique that can be scaled down to measure few virions, even single viruses, if it is possible. So what I have been doing in the last 5 years is to use the semiconductor theory to treat the virus in a suspension as impurity inside the semiconductor, and to come up with a parameter and figure of merit that will help us to decide if there is virus or not. Here, I would like to explain about the fundamental of electrical detection. Electrical detection means impedance. You are measuring impedance. You are applying voltage and you are measuring current, or vice versa. You apply current and you measure voltage. And the definition of the impedance is V over I. This impedance could consist of two parts, real part and imaginary part. The real part is related to the conductivity, while the imaginary part is related to the capacitance. Okay? And when you want to measure, you need a specific structure, that's we name electrical structure, that you need to load your suspension and to apply set of electrical condition and collect set of electrical responses. And when we do this, okay, like here in this, on the most right, you see that you always need a reference, okay? Of course, you need a reference. And this reference, for example, 1, and the other one, 2, line 2 is the where you load your virus. So without anything, you have 2 line parallel, okay? When you load, they attach this antigen to this antibody, this virus to antibody, okay? Then you have the red signal, there will be some modification, some changes, okay? And when you release it, also it will come back. So during this time here, this variation, we want to make use of this variation to find a way or methodology for virus detection. That's the principle, that you have a reference signal, and when you have a virus, you have a variation in the signal, and you need to work on this variation to quantify and identify the virus you have. Going more in deep about the principle of detection, this is a medium where you have viruses, like, for example, this is a blood, and this is, for example, could be coronavirus, okay, suspended there in the blood, okay? When we apply electric field, this is the field distribution going from positive to negative. And in figure C, you need alternating AC to measure the capacitance and the impedance as a function of frequency. And therefore, what you see that these viruses get polarized. So they have the ability to hold charges. And thus, they will change the capacitance or the conductivity of the solution. Okay? This figure show you the possibility to charge the suspension, the media, the VTM, the virus transfer media, the buffer, and the virus particle over time. And you see, this is the mock, only the solution, and this is when we have FIV, and this is when we have HIV. And FIV, by the way, is the HIV in cat. So you can feel with the same, this is for the same concentration, that the electrical signal varied corresponding to a reference one. What was my reference? Is the mock, the buffer. So therefore, we will be able to use these signals to develop our technique. So that's our technique. That's to find the number and the number of virus in a solution. And this is using the by volume, electrical volume. So what we are going to do, we are going to have the blood without anything, or the salivia, or the urine, or the nasal swab, without anything, just its media. And then we will measure set of electrical signals and extract set of parameters to find this to the by volume and number of impurities. And we will find this in the by volume and number of impurities in the reference signal and for the measured viral signal, okay? And then you will see that these parameters are changing, okay? As you see here, these parameters are changing. This is for MOC, this is for HIV virus. This is when we have VIV, here when we have water, here when we have silica. So you see these numbers are changing. And based on this number, I can go back and construct these two quantities, which will help me to quantify and identify, okay? Of course, there's, as I told you, you need to apply specific set of electrical condition and collecting the corresponding electrical signals and then process it. I think after that, you need to do some kind of validation. You come up with a new technique and you want to check that your technique is working well or not. So the best thing to do is to use conventional method, ELISA, for example, that can find the virus concentration, or this biomarkers and antibody-based techniques that can help you to identify, classify the virus in a suspension. Okay, and here you see the current method and the other conventional techniques, and somehow they have a good agreement. Principle of identification. Which virus is this? Of course, you have a set of viruses. You don't have one virus particle. Maybe you have million. Yeah. And the nice thing about electrical techniques that you can go down. You need a host structure, okay, to measure its capacitance or its resistance. This you can scale down with the help of nanotechnology to be able to measure a single virus. So a principle of identification here that you model your suspension to two zones, media and virus, okay? And then you subtract, assuming they are parallel connection capacitance, you subtract and you divide over the number of particles that you computed in the previous slide or previous quantification using quantification methods, equations. And then you can divide, and then you will find the capacitance per single virus. And after that, we find that this is the HIV. This is HIV, this is FIV, and this is silicon. You see, this is very nice data. So, of course, as I told you, you can measure the concentration with ELISA kit to find the loads and to make sure that your methodology is working or not. These are some results. Okay, this is single particle. This is the capacitance of single particle. This is silica. Silica is silicon oxide nanoparticles. This is HIV and this is FIV. Okay, you see, depend on the load. And this is the directly constant of each virus, which is that's a good way, strategy, foundation to be explore further, to build lookup table and identify as much as virus as you can. So concluding remarks here that the electrical characterization of biotic material exhibit and relieved that they can be used to develop a new class of bio-based components and systems that can help in quantifying and identifying. This can be scaled, transferred to lab-on-chip microsystem, and this will have a path to provide solution to the society problems and exploring scientific advancement and technology innovation through the engagement in high quality research and knowledge. And by focusing on these issues, this research culture is very important, multidisciplinary, sustainable work. And I believe that for this viral electrical detection, different people from different disciplines should work together, should work side by side, because electrical engineer by himself will not be able to do such interdisciplinary work. And this will have a huge impact on replying back to any outbreak pandemic in the future. So thank you for your attention. And if you have any questions, please feel free to ask.
Thanks to internet technologies, we are becoming much more connected, and that ubiquity and pervasive computing is becoming reality. We don't really have to travel, which may be a good and bad thing. A good thing indeed, because of pollution and perhaps issues related to virus propagation by travel. At the same time, it's also sad because then, of course, we cannot see and cannot meet colleagues in person. Now, my thought today about the global village and smart world, that we are just at the beginning of that age of smart world. What you see behind me is a Samsung library in Suwon, South Korea. And that is a library that was given as a gift by Samsung to Sangkyunkwan University. I used to work at Sangkyunkwan and basically work closely with Dr. Shin, who was then Dean of College of Information Communication Technologies. Now I believe he's the president of the university. And the university, working side by side with Samsung, have then, I remember 10 years ago, discussing the concept of smart university, smart city, smart world. And what we see that, of course, side by side with Japanese colleagues in Japan, and we see that automation, cyber automation, making huge progress. And at the same time, of course, we see it in US, Canada, and UK, and Europe. But I think the most perhaps dramatic kind of results or most significant results that we can actually see are in Korea and Japan, because yet they are smaller geographically nations. And yet you see that kind of impact, how they mastered this globalization and also technologies. Samsung, the same what Fujitsu and Sony and many outstanding companies in Japan are doing side by side. In Korea, they have managed to kind of start with this, what they call enterprise computing. And enterprise computing means that it is to offer services to businesses, government, industry. And we see that transformation with Industry 4, now, of course, moving on to Industry 5, connecting all these infrastructures with the 5G, and now transiting eventually to 6G networks. So that ultimately will create that ultra fast, ultra connected global village. Even the Ethernet infrastructure is kind of evolving with the huge data centers like Google, Amazon, Yahoo, Microsoft, Samsung, and many others, and of course, Sony, Fujitsu, and others in Japan. And we see it also throughout the China, India, and the South Pacific. There are some kind of starting initiatives on augmenting what they call enhancing the existing ICT infrastructure. So indeed, one of the factors that drives that development is miniaturization, and of course the cost, because as you see, almost every 3 or every 6 months, there is a new smart device available on the market. And of course, that definition of smartness, I think I mentioned it last time, is a concept of enhance functionalities. Indeed, when we look at smart in context of human intelligence, then I think computing technology has still quite a far to go to reach that level of reasoning and sensing and thinking and decision-making compared to intelligent, well-educated human beings. Now, of course, AI, machine learning, and humanoid robotics is becoming part of that smart computational world. And of course, with this evolution, we'll see that, perhaps the Hollywood movies like AI, which may sound somehow far-fetched, but now they're becoming more and more reality. We see the humanoid robot like Sophia, and of course, more advanced robots now that can actually create or provide services to people at home. Of course, technology is a wonderful thing if it respects free common law of robotics. Of course, robot must not injure, robot must obey, robot must basically be of service. And at the same time, now we have a couple of other, say, sub-routines that robots are learning from other robots. So they have their own robotic Ethernet. And with that, what we see, because of machine learning, that the machines can learn from other machines. Like we humans, when I talk to Professor Akashi, and let's say we will talk about engineering in general, I will learn many things from him. And hopefully, I may have some ideas that Professor Akashi may find interesting, or colleagues, here joining our conference. So we're learning from one each other, but we do it through audio, which is naturally because we have sensing capability of hearing, and we see, and we can actually, when we meet in person, we can actually relate to other, say, sensing capabilities as human beings. Machines, they don't have that sensing capabilities yet. All they have is the information that's been processed and given to them as an instruction to act. So in that respect, you see that mechanizing kind of a mechanical, to some respect, structure compared to that naturally neuro-human biological structure. Now, what we see at the same time, we see also trends to bring that neurocomputing and quantum computing that would speed up the computation to a much higher degree. And of course, machine capable of being built with the bio and quantum technologies in the future will be machine that can very much assimilate human behavior, and they can very much actually assimilate even that learning and decision-making capabilities. Indeed, what machines may have difficulty to achieve is that sense of values. In other words, we've been taught that what is right and what is wrong, and that goes through traditions. Our parents have taught us to behave, and of course their parents. And so we look at the traditions of our grandfathers and predecessors, and we carry all these values and traditions and stories, which in machine learning, this would mean that they would be able to enhance that dimension of values. And of course, that is something that if a malicious programmer can basically, yet again, through cyber attack, impact or change or reprogram that machine, so that machine can become a very malicious and very damaging device. Of course, same with humans. Humans can become, beautiful people get corrupted through drugs, through alcohol, through money. So again, that brings us to the dimension of morality. And again, I'm a computer scientist, and I just want to kind of bring the dimension, but it would be naive to ignore that there is something that is essential for human society to make sure that people have good life. And if we have society that is now full of machine, super smart, intelligent, ultra smart machines, that also these machines or these computational devices will have some sense of values, and perhaps they would at least be able to withstand or stay within the norms of morality. In other words, that despite of, I give you a scenario, if you have a super smart humanoid robot at home, and that robot is helping your grandmother or yourself or your child or your grandchildren, and imagine that robot is basically developed a learning path. He knows how, almost, I don't say he recognizes, but he have learned, he have collected information from daily interaction with humans. And so he set up his kind of a normal, what we call normality behavior. And suddenly through cyber attacks, any anomalies, any reprogramming of that machine can suddenly make that machine most dangerous device at home, because it can virtually harm and, God forbid, even kill human beings at home. So we see a lot of robotics, and I think Professor Akashi could comment that, in Japan, you see that home robots that have been now so popular, and they are very wonderful. They are, really fantastic machines that, you can actually have device that is helping, because, with age.
Thank you so much. Thank you so much.
Yeah, please, Professor Akashi, what are your thoughts on that smart robotics at home? Konnichiwa. You can say a couple of words, Professor Takashi. It's okay. You can interrupt, please. Anyway, so yeah, please go. I mentioned in Japan, do you have a home robot in your own home, Professor Takashi?
Exactly speaking, I have no robot in my home, but in my university, I am a member of developing the home caring robots.
Well, you see, I knew it.
I am now majoring in the security part of home caring robots. Yes.
You see. So you agree.
Thank you so much for your interest.
Thank you.
I'm very surprised to hear that. Thank you so much.
Yes, well, I know, because I remember even in the 1970, like 50 years ago, robotics, I actually did my engineering project in the Institute of Robotics. And of course, you remember, Professor Akashi, we had these analog computers, the panels, analog computers connecting the panels. But actually, even today, then I often ask my graduate students or colleagues, which computer is more precise, analog or digital? Many students or many colleagues would say digital, but actually no, it's analog computer, because it's continuous signal. So there is no randomness, there's no discrete values, it's all continuous. And same, you see, one of the problem is that we have these human being, as humans, we are, I say, analog based, if you like, creatures, yeah, because it's all continuous. Now, if you take a machine, all these machines are based in the discrete principles of discrete, basically mathematics and discrete values. And so the question is, with the biotechnology, perhaps what you call digital machines could become bio-digital machines, or perhaps, so that level of smartness, that level of decision-making and learning. And surely, Professor Akashi, you know of Professor Su-Kan Lee from Sangyungwan? He has a lab.
I have ever heard of him.
Yeah.
But I'm sorry, only of his name. I'm so sorry.
Yeah, well, I used to work with Professor Su-Kan Lee in his lab, and he's now retired. He's
retired.
Yeah, but I mean, and of course, with the colleagues in Washington, Professor Blake, he worked on a surgical robot. And you know, the surgical
really?
robot.
Yes. Surgical
so-
robot.
Yes, indeed. And one of the problems with the surgical robot, if you take a surgeon, a person who performed the surgery, that person may commit an error due to fatigue. Because, you know, if the person is tired or stressed, and there's a very delicate operation or manipulation of whatever, so he or she may cause an error. But the machine,
Yes, exactly.
Machine can be programmed precisely, but the only problem with the machine, that machine cannot do that natural reaction to the event that happens that people can do. In other words, if there's a bleeding, if there's something, suddenly complication, blood pressure changes, machine is programmed to finish the operation, to conduct that process to the end. And yet humans can interrupt, humans can adapt. So that, in that sense, I think there's a lot of challenge as far as robots is to be able to react in real time to real-time scenarios. Yeah, because that real-time reaction requires a huge amount of computation through visualization, through sensing, through measurements, through geometry. And of course, we humans, we do it naturally. It's like, you look at, if I have that cup here of coffee, so what I do, I basically know exactly how much coffee and I'm not going to spill my coffee on my table. But robot, and I can still talk to you, I can still notice people behind me, or I can notice situations, and I can sense a car driving, passing my house. But of course, the robot can only sense or can only process set of instructions that it was given. So it's a computational task. And so the question is, how do we translate computational task to an event that you, I, every human being does it naturally? So that naturality of a task, how does the computer learn? So I think the next level of futuristic computing, and of course, they will contribute to global village, because I think if humans cannot make peace, you know, you see what happens, that people often don't understand, don't respect each other. And you see wars and misunderstanding and hurting and God forbid. But robot would have that sense of morality and sensibility that maybe they can even contribute to a better world. Of course, this is very naive and maybe very far-fetched. But what I'm trying to say, that the next generation of robots are now robots that will be able to learn not just from the computational, virtually tapping into,
yes, exactly,
but from humans. And how do we do that?
Yes, not computational education, but human heart, yes, human heart should be educated, yes. Perhaps
And of course,
just the computer scientist having developed the surgical robots told me that what is I remember now, I am not remembering. So yes, how to educate the difficult. There is the surgical difficulties accompanying with the interface between the analogous programs, especially located in human bodies, and the computer treatments, which is exactly expressed with the digital formation. So, and yes, how to educate the surgical robot, which can play themselves, which can play themselves in our on our behalf.
Agree.
Yes. So with morality, yes, with human hearts, I think so.
Indeed,
Thanks so
because
much.
what you see,
You are suggestive ideas.
Well, and again, you know, the cybersecurity is just a very minor part of it, very important. But in other words, when you have a robotic infrastructure, you really have to make sure that you have ultimate cybersecurity. Because, you know, I give you an example. When you or I or colleagues go out and we see the old lady crossing street, naturally,
thank you so much.
Your instinct telling you to help, or if you see anything to protect. So that instinct, what we call human instinct, how do we learn a robot to become, to adopt human instinct behavior?
Yes, yes, yes. But it seems to be so difficult problem to be solved.
Very difficult. And in addition to instinct, you have that intuition. You kind of feel like you have that extra feeling. And again, we come to that, you know, almost philosophical word. But this is where I would say today, when we talk about futuristic technologies, we have to be open-minded to look at that the machines are, at the moment, very vulnerable to human impact. In other words, if the machine would reach that level of intelligence and decision-making capabilities, that they would be, through the education, as you mentioned, because, you know, you look at your students, your colleagues, and of course, these people have been educated, and every part of education is also that embedded morality and sense of values. And, you know, because I think this is where I feel very much important, looking at the world, what's going on, that it is important that we have generations of good people, of good engineers, of good scientists.
Yes, exactly.
Of people who have that sense of responsibility, that if they can influence anything, or if they can build any machine, that machine can only help people. It must not abuse, it must not hurt, it must not endanger people. And so, and of course, that these values. So I think perhaps, you know, I would be most honored, Professor Akashi, if ever, you know, we could maybe interact. And I love to visit your lab, hopefully one day when.
Oh, thank you so much for your invitation.
I would be most glad to come to visit. And, you know, we could do this kind of, I think, because it seems like you have made already a lot of progress. And yet, you see, when you get to that level of what we call cutting edge technology, suddenly you realize, my gosh, we've forgotten about this.
Oh,
so it's
thank
always,
you so much.
Indeed. So,
your message has encouraged me and my motivation.
Indeed. Well, I'm so
thank
glad.
you so
And
much.
also,
Heartful encouragement.
Yes, you're most welcome. And also, I hope and believe that other colleagues, you know, I give you an example with this, working with the PhD students, because the PhD students, I believe, are the people who will take that research much farther, because they have many years to go. You know, we are at that age when I say, you know, every day is a gift, and every day is a gift. But of course, we have a lot of ambitions and we have a lot to give. But I think it's important to educate, and not, you know, apart from mathematical rigor and engineering rigor, we also have to educate these young people to have their imagination capabilities. So they must not forget that actually the robot are today, I look at these most advanced robots today as a small baby that is learning to walk.
Yes, exactly. Yes.
And yet
like a small baby.
And they are supercomputers, but they still need to speak properly.
The growth of small babies, yes, depends on how to be educated. Yes.
I agree. And yes. that education, you see, now we are shifting from curriculum, which is known as a typical university curriculum, to perhaps educational curriculum for the machines, or machine curriculum, where you have different levels, and you say, okay, this robot now has passed a graduate, a kindergarten. This robot has passed elementary school. This robot has passed secondary school. And by giving that the recognition, you see, so what you have, you could establish certain degrees of intelligence as far as the machines. And you could,
the more
then use-
humanoid our robot is, the more, yes, heartful education should be required, you say, I think.
I agree.
Yes.
I agree.
Yes. So
because then you
perhaps
say,
from now, sorry, please.
I remember talking to colleagues in Japan, in Tokyo, one of the professors from University of Electrotechnology and the University of Tokyo of Technology mentioned that, you know, they, like languages, look at when European or American goes to Japan, and if they get to metro, it's completely impossible to figure out where should they go unless they speak very well Japanese. And so even that language recognition or instant translation is something that, you know, if I would come to Tokyo, you would hopefully you would meet me at the airport and you will say, Professor Bablak, we go here and here.
Of
so
course.
You guide me. But
of course.
But now imagine having that robot, that universal robot, that would be able to take you to France, take you to Spain, take you to Abu Dhabi, take you to anywhere in the world and translate and guide you, because that robot can learn geography, he can learn local language, he can learn local infrastructure, everything. And of course, so that is that level of intelligent, distributed, smart database that we humans just observe by asking questions. Excuse me, how could I get here? And we remember, you see, and we enhance our memories with places that you recall and say, oh, I know. And you can go on your own now to Los Angeles, you can go on your own to Rome because you've been there. So you know how to get by. But if it's a first time, so, and that is that learning curve, you see, that we would need to figure out how to establish a learning path for the machine. So suddenly from doing anything locally within the geometry of your house, Professor Akashi, Raju, we have basically touched that I mentioned smart global village. And I think the ultimate drive behind this is the smart robotics or humanoid robotics, because these will be the machines that are much beyond what we call smartphone. The robot will be smartphone on its own. I close this and I thank you, Professor Akashi, and thank you, Raji, and thank everybody. And I'm open to any questions. Thank you.
Thank you so much. I would like to say my hearty gratitude directly to Professor Bablak. Thank you so much. I have had Cisco told me that from now on, in the forthcoming cyber world, each computer researchers, each computer researcher may have each avatar, which can activate in the cyber world. Not so in the near future, your avatar and my avatar can meet in the cyber world in anywhere.
And they can translate our thoughts and have a dialogue as if we would do it ourselves.
Thank you so much.
Thank you.
The same to you, Professor. I enjoyed your talk, your research talk. Thank you so much.
Thank you. Thank you.
I think it is better to give Professor Bablak for this opportunity to speak about the conference. I think he will guide us better than me to how to still improve the conference, and because they are senior professors, so they can guide something for us. You can ask Professor Bablak to give some information how to improve in a better way, the same your organizing and all those things, and how to make the interaction and how to. The normal procedure is yes, we are the professor will give a talk and then the questionnaires are asked, but still in a better way. What are the improvements that can be done? Professor Bobula, I request to give some guidelines so that the outcome should be fruitful to all. And I feel, of course, Professor Nawaz is preparing all these talks in the form of soft copy. So that is all, and he's launching in the open website also. So, and he's also emailing to all the participants. So what I feel is in a broader way, how still we can elaborate and communicate with more people and make the conference a very good success. Because conference means